It is 3 in the morning. You're lying in the dark, staring at the ceiling, and your mind drifts somewhere it shouldn't. A moment you wish you could undo. A conversation you'd give anything to have again. A person whose face you can barely remember now, but whose absence shaped everything that came after. The silence around you feels heavy, almost alive, and in that stillness, you ask yourself the question that has haunted humanity since we first became aware of time itself. What if you could go back? This isn't just your question, it belongs to everyone. The grandmother in Manila who lost her daughter too young. The businessman in London who made one wrong choice that collapsed his entire life. The teenager in Sao Paulo who wonders what would happen if she could see just 5 minutes into her own future. Different lives, different languages, different centuries, but the same impossible wish threading through all of human consciousness. We want to break free from time's forward march. We want control over the one thing that controls us. History whispers about this longing in ways we've learned to ignore. Ancient Sanskrit texts describe sages who moved between yugas, vast cycles of time, as easily as stepping through doorways. Mayan priests recorded calculations so precise they predicted celestial events thousands of years ahead, as if they'd already witnessed them. Medieval philosophers wrote encrypted manuscripts exploring whether the past still exists somewhere, untouched and accessible. They weren't writing fantasy. They were documenting a question that refused to disappear, and here is what makes it stranger. That question never went away. It just moved from temples and libraries into laboratories. Scientists today, physicists with equations longer than most novels, researchers at institutions you'd recognize, are investigating the same possibility those ancient texts suggested. They use different words now. Closed timelike curves, retrocausality, quantum temporal displacement. But underneath the terminology, they're asking the same thing humanity has always asked. Can we escape the river of time, or are we forever trapped in its current? There is a question that keeps scientists awake at night. Not because they don't know the answer, but because they're terrified they might be right. Because what if time travel isn't impossible? What if we've simply been searching for it in the wrong places, looking for machines and portals when the evidence has been hiding in historical records, in unexplained moments that science dismissed too quickly, in anomalies that don't fit the neat story we tell ourselves about how time works? What if the proof isn't in some future laboratory, but scattered throughout history, waiting for someone to recognize the pattern? Throughout every era, across every continent, strange things have happened that seem to violate time's supposed rules. Accounts that were archived and forgotten, incidents that were explained away, phenomena that made people uncomfortable enough to stop asking questions. The official story says time moves in one direction, that the past is sealed and the future hasn't happened yet. But the official story has been wrong before. Something extraordinary might be hiding in plain sight. And if you're willing to question what you've been taught about the nature of time itself, what comes next might change everything you thought you knew. But first, we need to confront something that seems to make the whole idea impossible. The official narrative is simple. Time moves forward. The past happened. The future hasn't. Anything that suggests otherwise must be a mistake, a hoax, or a misunderstanding. This is what we retaught, what textbooks repeat, what experts reinforce whenever someone asks uncomfortable questions. But here is what they don't tell you. Throughout history, there have been moments that don't fit this neat explanation. Moments that were documented, investigated, and then quietly filed away because no one knew what to do with them. In 1950, a man walked into a New York hotel wearing clothes from 1876. He had currency that hadn't been printed yet, and then he vanished. This isn't fiction. His name was Rudolph Fentz. Police found him disoriented in Times Square, dressed in Victorian-era clothing that wasn't a costume, but genuine period attire down to the stitching. In his pockets, they discovered old currency, business cards from companies that closed decades earlier, and a letter dated 1876. He seemed confused by the cars, the lights, the world around him. Before officers could get answers, he bolted into traffic and died. When investigators traced his identity, They found records of a man named Rudolf Fentz, who disappeared without explanation in 1876. Same name, same description. 74 years apart. Science says this must be fabrication or coincidence. But the police report exists. The investigation happened. And Fentz's case isn't T alone. Consider the artifacts that shouldn't exist. In Romania, workers discovered an aluminum wedge buried in geological strata dated to 200,000 years ago. Aluminum was isolated by humans until 1825. The wedge was tested repeatedly. The results didn't change. It is there, it is real, and it shouldn't be. In an ancient Roman shipwreck from 2,000 years ago, divers found a corroded mechanism that, when reconstructed, turned out to be a precise astronomical calculator with gear systems that historians insist shouldn't have existed for another millennium. Scholars call it the Antikythera mechanism. They can describe what it does. They struggle to explain how anyone built it. Then there are the people who knew things they could know. Mark Twain documented a dream about his brother's death in a riverboat explosion, including specific details about the funeral arrangement. Weeks later, it happened exactly as he described. A psychiatrist named John Barker investigated 76 people who reported dreams about a coal slide destroying a Welsh village called Aberfan. Days later, the disaster occurred, killing 144 people. The dreamers described details they never encountered. The village name, the black material sliding down, children in danger. Barker documented everything before the event. Statistical analysis showed the clustering of these premonitions exceeded any reasonable probability of chance. Mainstream science has explanations. Coincidence, false memory, hoaxes, misidentification, archaeological anomalies that will make sense once we understand ancient techniques better. And perhaps that is true. Perhaps every single one of these incidents has a conventional explanation that doesn't require us to rethink the nature of time itself. But what if the simplest explanation has been overlooked precisely because it seems impossible? What if we've been trained to see time as a one-way street when it is actually something far stranger? A landscape with paths that loop back, intersect, or exist outside sequence entirely. Over the course of this investigation, we examine evidence from multiple directions. Physics that suggests time travel isn't just theoretical, but potentially inevitable under certain conditions. Historical accounts that were dismissed too quickly. Psychological studies showing humans can respond to events before they happen. Documented anomalies that refuse to fit the official story. Separately, these might seem like curiosities. Together, they paint a very different picture of what time travel might actually be. But before we can evaluate whether time travel is real, we need to understand something more fundamental. What is time? And that question takes us somewhere unexpected. This isn't going to be another surface-level exploration of time travel tropes and Hollywood fantasies. What you're about to encounter is something different. An investigation that follows evidence rather than entertainment, that asks uncomfortable questions rather than providing easy answers. We're going to examine time travel from angles most documentaries ignore, and some of what we uncover might challenge assumptions you've held your entire life. The journey ahead moves through several territories. First, we'll explore the physics, not simplified metaphors, but what Einstein's equations actually say about time's nature, what solutions exist in accepted scientific literature that allow for temporal manipulation, and why mainstream physicists often avoid discussing the full implications of their own mathematics. We'll examine theories from Nobel Prize winners and classified research from government laboratories, not fringe speculation but peer-reviewed findings that suggest time isn't what we've been taught. Then we'll turn to history. Ancient artifacts that shouldn't exist, documented cases of individuals who possessed knowledge they couldn't have acquired through normal means, incidents that were investigated, recorded, and then quietly archived because they didn't fit acceptable narratives. We'll look at what happened when serious researchers tried to study these anomalies and why their findings often disappeared from public discourse. We'll also examine experiments happening right now, quantum physicists measuring effects that occur before their causes, consciousness researchers documenting human responses to future events, laboratories testing whether time's arrow can be reversed, even briefly, under controlled conditions. Some of this research is published in obscure journals. Some remains classified. By the end of this investigation, you'll know why governments classify time research, and why some scientists refuse to publish their findings. But this investigation goes deeper than machines and equations. We'll confront philosophical implications that might be more disturbing than the technology itself. Questions about free will, about whether the future already exists, about what it means for consciousness to potentially exist outside linear time. These aren't abstract puzzles, they're questions with profound consequences for how we understand reality, choice, and existence itself. Now, let's address something directly. Extraordinary claims require extraordinary evidence. Skepticism isn't just healthy, it is necessary. If you approach this investigation looking for definitive proof that will convince every scientist on Earth, you'll likely be disappointed. What we can offer is evidence that has been overlooked, patterns that emerge when you examine multiple fields simultaneously, and questions that mainstream science has struggled to answer satisfactorily. This isn't about believing, it is about investigating. We'll present what the scientific establishment says alongside theories they've dismissed. We'll show you documented anomalies and the conventional explanations offered for them. Then you can decide which explanations actually fit the evidence and which ones feel like intellectual avoidance of uncomfortable possibilities. Some of what you'll encounter might seem impossible. Some might feel uncomfortably plausible. By the end, you'll have information that challenges fundamental assumptions about cause and effect, about whether the past is truly fixed, about the relationship between consciousness and time itself. Whether that information changes your worldview is entirely up to you. But first, we need to establish a foundation. Before we can evaluate whether time travel is possible, we need to understand what time actually is, and that takes us somewhere most people never expect. In 1905, a patent clerk in Switzerland published a paper that should have ended the conversation about time travel before it began. Albert Einstein's special theory of relativity seemed to seal time into an unchangeable framework, a cosmic speed limit that kept past and future forever separated. That is the story most people know. But there is another story, one that Einstein himself found deeply troubling, hidden in the mathematics he de-unleashed on the world. Einstein's equations predicted something so disturbing that he spent the rest of his life trying to prove himself wrong. He failed. What disturbed him wasn't just that time could slow down. That much became famous. The twin paradox, where one twin travels near light speed and returns younger than the sibling who stayed home. It is a thought experiment that sounds like fiction, except it isn't. In 1971, scientists placed atomic clocks on commercial airplanes and flew them around the world. When the planes landed, those clocks had measured less time than identical clocks on the ground. Not by much, just fractions of a second, but enough to prove the impossible. Time had literally moved slower for the traveling clocks. The experiment has been repeated dozens of times with increasingly precise instruments. The results never change. Time is not constant, but here is what textbooks often skip. If time can slow down, if velocity and gravity can manipulate its flow, then time is what we think it is. We've been taught to imagine time as a river carrying everything forward at the same rate, an invisible current that affects all of us equally. Einstein's equations say something different. They suggest time is more like a landscape, terrain with hills and valleys where clocks run faster in some locations and slower in others, where the passage of moments depends on where you are standing and how fast you are moving. And if time is a landscape, then perhaps there are paths through that landscape we haven't considered. Perhaps there are routes that loop back on themselves. Einstein's field equations, the mathematical heart of general relativity, don't just allow for time dilation. They permit solutions called closed timelike curves. These are paths through space-time that circle back to their own starting point, not in space but in time. Follow one of these curves far enough, and you arrive back at the moment you started, before you left. The mathematics doesn't prohibit this. In certain configurations of mass and energy, these curves are perfectly valid solutions to Einstein's equations. When physicists first discovered these solutions, they assumed something must be wrong. Surely there is a hidden rule, some principle that prevents closed timelike curves from existing in reality, even though the mathematics allows them. They searched for that principle. They are still searching. No one has found a fundamental law that forbids time loops from forming under the right conditions. Einstein knew about these solutions. In private letters to colleagues, he expressed unease about what his own equations implied. He suggested that perhaps there is something incomplete in general relativity, some missing piece that would eliminate these troubling possibilities. He explored alternative formulations. He collaborated with other physicists to find ways around the implications, but the mathematics remained stubborn. The equations that successfully predicted everything from the bending of starlight to the existence of black holes also predicted that time travel might be woven into the fabric of the universe itself. This is where most documentaries stop, treating these solutions as theoretical curiosities with no connection to reality. But that is not where the story ends, because after Einstein, other physicists took these implications seriously. They asked a simple question: if the mathematics allows time travel, what would it actually take to make it happen? What they discovered opened doors that some wish had remained closed. Doors that lead to places where time doesn't flow the way common sense demands, where the future might reach backward, where yesterday could be somewhere you could actually go. Einstein gave us equations that described reality with stunning accuracy. But those same equations contained possibilities he found so disturbing that he spent decades hoping they were wrong. They weren't. And some physicists decided to explore what that really meant. In 1949, Albert Einstein celebrated his 70th birthday at Princeton's Institute for Advanced Study. Among the scholars who gathered to honor him was Kurt Gödel, a mathematician whose work had already revolutionized logic and mathematics. The two had become close friends, taking daily walks through Princeton's streets, discussing everything from politics to philosophy to the deepest questions of physics. Gödel had been working on something he hadn't shared with Einstein yet, a mathematical solution that would become his birthday gift to his friend. It was a gift Einstein would find impossible to refuse, and equally impossible to accept. In 1949, a mathematician proved time travel was possible. His best friend Einstein couldn't find a flaw in the proof. Neither can anyone today. Gödel had taken Einstein's field equations, the same equations that described gravity, the curvature of space-time, the motion of planets, and found a solution no one had anticipated. He described a universe that rotates, not the galaxies within it, but the universe itself, spinning around a central axis. In this rotating universe, Gödel demonstrated mathematically that closed time-like curves exist naturally, travel far enough in one direction through space, and you eventually arrive back where you started, but in your own past, before you departed. This wasn't speculation. It was rigorous mathematics using Einstein's own framework. Gödel showed his work to Einstein privately before publishing. According to colleagues who witnessed their conversations, Einstein studied the equations carefully, searching for an error that would invalidate the conclusion. He found none. The mathematics was flawless. Einstein's own equations, applied to a rotating universe, permitted time travel as a natural feature of space-time geometry. The implications were staggering. If Gödel's solution was mathematically valid, and no one could prove otherwise, then time travel was some exotic phenomenon requiring unknown physics or impossible technologies. It was built into the structure of reality itself under certain conditions. The universe Gödel described wasn't science fiction. It was a legitimate solution to the equations that had proven correct in every other test. Physicists scrambled for a way out. They argued that while Gödel's mathematics were correct, they described a universe fundamentally different from our own. Observations suggest our universe expands rather than rotates. Therefore, Gödel's solution, though valid, doesn't apply to actual reality. The crisis was averted. Time travel remained safely theoretical, locked away in a mathematical universe that doesn't match the one we inhabit. But that response raises a more disturbing question. If the mathematics of general relativity allows time travel in a rotating universe, what does that reveal about the nature of time itself? The equations don't distinguish between possible and impossible. They simply describe what space-time can do under various conditions. If time can loop back on itself in one configuration, then time isn't fundamentally linear. It is something more flexible, more strange, capable of geometries our intuition refuses to accept. Gödel himself seemed unsurprised by the discomfort his discovery created. He spent his career proving that mathematical systems contain truths that can be proven within those systems themselves, that logic has limits, that certainty is rarer than we like to believe. His time travel solution fit that pattern, a demonstration that reality, even constrained by Einstein's equations, was weirder than anyone wanted to admit. The discovery created what one physicist later called a quiet crisis, not a public controversy. The implications were too abstract for headlines, but a deep philosophical unease among those who understood what Gödel had done. He'd shown that the same equations describing gravity on Earth and the orbit of Mercury also permitted grandfather paradoxes and causal loops. The mathematics didn't care about our discomfort with time travel. It simply showed what was possible. Einstein never publicly rejected Gödel's solution. He could the mathematics worked. Instead, he seemed to retreat into hoping that some future discovery would explain why Gödel universes, though mathematically valid, could exist in reality. That explanation never came. Gödel's equations remain as valid today as they were in 1949, a permanent reminder that Einstein's greatest achievement also opened a door he'd rather have kept closed, but Gödel's rotating universe wasn't the only way through that door. Other physicists found different paths, different solutions that suggested time travel might be possible even in a universe like ours. While Gödel explored rotating universes, other physicists found something else hiding in Einstein's equations. They called them Einstein-Rosen bridges, though most people know them by a simpler name, wormholes. These theoretical tunnels through space-time weren't invented by science fiction writers. They emerged naturally from the mathematics of general relativity, representing another way that Einstein's equations permit connections between distant points in space and time. The basic concept sounds almost reasonable. If space-time can curve, perhaps it can curve so dramatically that two distant regions connect through a shortcut, a tunnel bypassing the normal distance between them. Walk through one end of the wormhole, emerge instantly at the other, potentially light years away. For decades, this remained an interesting mathematical curiosity. Then, in 1988, a physicist named Thorne asked a different question. Not whether wormholes could connect distant places, but whether they could connect distant times. In 1988, a Nobel Prize-winning physicist published a paper explaining exactly how to build a time machine. The paper is still cited today. The research continues in private. Thorne, who would later win the Nobel Prize and consult on the film Interstellar, published his findings in a peer-reviewed journal. His conclusion was unsettling. If wormholes exist, they could be converted into time machines through a process that doesn't violate any known laws of physics. The mechanism relies on something Einstein had already proven: time dilation. Imagine creating a wormhole with two mouths, two openings connected by the tunnel through space-time. Initially, both mouths exist in the same time frame. Now take one mouth and accelerate it to near light speed, perhaps on a spacecraft circling the galaxy, while leaving the other mouth stationary on Earth. Einstein's relativity tells us what happens next. For the traveling mouth, time passes more slowly. This isn't theory. It is the same time dilation proven by atomic clocks on airplanes, just more extreme. After the journey, bring the traveling mouth back to Earth. Here is where it gets strange. The two mouths are now synchronized in space, sitting side by side, but they no longer synchronized in time. The traveling mouth has aged less than the stationary one. Step through the stationary mouth. and you de-emerge from the travelling mouth not just in a different place, but in its past, which is also your past, because the travelling mouth exists at an earlier time than the stationary one. You've travelled backward in time, not through some exotic unknown physics, but through relativity and geometry. Thorne's paper didn't just speculate, it worked through the mathematics rigorously. Other physicists examined it, searching for flaws. The conclusion held. If wormholes exist and can be manipulated, they become time machines almost automatically. The physics is sound, the method is clear. Only the engineering remains impossible, for now, because there is a catch. Wormholes, according to the equations, collapse instantly unless held open by something with very unusual properties. Negative energy. Not antimatter, which has positive energy, but truly negative energy that pushes outward instead of pulling inward, that counteracts gravity's crushing force. For decades, physicists assumed such matter could exist. It seemed like a convenient impossibility, a loophole that kept time travel safely theoretical. Then quantum mechanics offered an uncomfortable surprise. The vacuum of space isn't empty. It seethes with quantum fluctuations, particles and antiparticles blinking in and out of existence, energy borrowed briefly from nothing. And some of these fluctuations exhibit exactly the properties needed: negative energy density. The Casimir effect, demonstrated in laboratories since 1948, shows that quantum vacuum fluctuations can create measurable negative pressure between metal plates. It is a tiny effect, but it exists. Recent experiments have gone further. Researchers have detected signs of negative energy in quantum systems, measured effects that shouldn't occur if space contains only positive energy. These aren't definitive discoveries of exotic matter, but they hints that the universe contains stranger ingredients than classical physics imagined. If negative energy exists naturally at quantum scales, perhaps it could be concentrated, amplified, harnessed. And here is what rarely gets mentioned outside classified briefings. Governments have funded wormhole research. DARPA explored theoretical studies in the early 2000s. Private research institutions with ties to aerospace and defense industries have published papers on space-time engineering. The research is quiet, technical, buried in journals most people never read. But it is happening. Serious physicists with legitimate credentials are investigating how to manipulate space-time geometry, how to create and stabilize wormholes, how to build structures that Einstein's equations permit. This isn't fringe science conducted in basements. It is mainstream physics, exploring the implications of accepted theories. The fact that research continues, that funding flows, suggests someone considers this more than academic curiosity. Perhaps they know something about negative energy or space-time manipulation that hasn't reached public literature. Or perhaps they were simply preparing for possibilities that seem distant but not impossible. Einstein's equations opened doors. Gödel proved some doors lead to the past. Thorne showed how to build those doors if we have the right materials. The only question remaining is whether the universe provides those materials, or whether we can create them ourselves. But equations and theories only take us so far. The real question isn't whether time travel is mathematically possible. It is whether anyone has actually experienced it. July 1954. Tokyo's Haneda Airport processes hundreds of international travelers each day, and customs officials have developed an instinct for irregularities, a nervous glance, hesitation with documentation, inconsistencies in travel history. But the man who approached the customs desk that summer morning showed none of these signs. He was calm, well-dressed, fluent in multiple languages. His demeanor suggested someone accustomed to international business travel. He handed over his passport without concern. The customs officer opened it and paused, then called his supervisor. His passport was perfect. His documents were flawless. The country he claimed to be from didn't exist, and then he vanished from a locked room. The passport identified him as a citizen of Taured. The officer had never heard of such a country, and asked the traveler to point it out on a map. The man stepped to the wall map, studied it briefly, and placed his finger on a small region between France and Spain, the location occupied by the Principality of Andorra. But according to him, there was no Andorra. This was Taured, had been for centuries. His confusion seemed genuine, deepening into distress as officials insisted no such country existed in any atlas, any political registry, any historical record. They examined his passport more carefully. The document appeared authentic, high-quality paper, official-looking seals, watermarks that seemed legitimate. More troubling were the stamps inside, multiple entry and exit stamps from countries around the world, suggesting years of international travel. Several stamps indicated previous visits to Japan. The passport showed he'd been here before, had cleared customs before, had conducted business in Tokyo on multiple occasions. But the issuing country didn't exist. Officials searched his belongings. He carried currency from several nations, some of which customs officers recognized. Others they didn't. Business cards identified him as a representative of a European company that, when contacted, had no record of existing. Yet he also carried correspondence and documents related to meetings scheduled with Japanese firms. When officials contacted these companies, some employees claimed to remember meeting him on previous trips, but there were no records of such meetings in company files. No invoices, no contracts, no paper trail supporting what people seemed to remember. The man himself grew increasingly agitated. He insisted his company existed, that Taured was real, that something was terribly wrong with everyone else. His understanding of geography and history. He wasn't argumentative, but bewildered, as if he'd stepped into a world that resembled his own, but had changed in fundamental ways. Officials didn't know what to make of him. He hadn't committed a crime. Exactly, his passport might be fraudulent, but it was so well made that even experts could identify how it had been forged. His story was bizarre, but told with such conviction and detail that dismissing him as a simple con artist felt insufficient. They decided to hold him overnight while investigators checked his claims more thoroughly. They took him to a hotel near the airport, placed him in a room high above ground level, and stationed guards at the door. There was no balcony, no fire escape, no way out except through the guarded entrance. They kept his documents for examination. The next morning, the guards opened the door to an empty room. The man had vanished. His belongings were gone. When officials checked the documents they deconfiscated, those had disappeared as well. The hotel room showed no signs of forced exit, no opened windows, no disturbance, suggesting an escape. He had simply ceased to be there. Investigators found no trace of him. No exit from the hotel was recorded. No taxi picked up anyone matching his description. He hadn't boarded flights leaving Tokyo. He didn't appear in any database or registry. It was as if he never existed, except for the testimony of multiple customs officers, security personnel, and business contacts who remembered encountering him. The case file remained open for years. Eventually it was archived without conclusion. Some researchers later claimed the entire story was an urban legend, a tale that grew in the telling with no factual basis. Others pointed to Japanese airport records from 1954 that contained anomalies, entries without corresponding exits, documentation gaps during the relevant time period, references to an incident that was never fully explained. Whether this specific case is true remains debated. But here is what isn't debated. Similar reports appear throughout history. Airports and border crossings worldwide have documented encounters with travelers presenting credentials from places that don't exist, haven't existed for centuries, or exist but with different names and borders than official geography records. Not frequently, but persistently, a pattern scattered across decades and continents. One strange case might be coincidence or fabrication, but patterns suggest something else. Something that keeps appearing in the gaps of official records, in the moments when someone crosses from one place to another and briefly, impossibly, seems to belong to a different version of reality. October 1943. The official record states that the USS Eldridge, a destroyer escort, was commissioned in New York and spent the following months on routine convoy duty in the Atlantic. The crew experienced nothing unusual. The ship's log documents standard naval operations. According to every official source, nothing extraordinary happened aboard the Eldridge during the war years. But between 1943 and 1952, several men appeared at different naval hospitals and psychiatric facilities with a different story. They claimed they'd been aboard the Eldridge during an experiment that went catastrophically wrong. An experiment involving powerful electromagnetic fields, invisibility, and something that fractured their relationship with time itself. 3 sailors walked into different hospitals, claiming time had fractured around them. Their medical records showed symptoms doctors had never seen before, or since. Most accounts of the Philadelphia experiment focus on the alleged event itself. The ship disappearing, reappearing miles away, sailors fused with metal bulkheads. These details are dramatic but impossible to verify. What is more interesting and more documented are the medical cases. The men who sought treatment years after the supposed event, men whose symptoms didn't fit any known pattern of trauma or psychological disorder. Dr. Arnold Rinehart, a Navy psychiatrist stationed at Bethesda Naval Hospital in 1947, treated one of these men. Rinehart's private journals, discovered after his death and partially published by his family, describe a patient who presented with profound temporal disorientation, not confusion about what day it was, but confusion about what year it was, what had happened and what hadn't. The patient insisted he remembered events from 1948 and 1949, events that according to hospital records hadn't occurred yet. When those dates arrived, some of his memories proved accurate. Details he could have guessed, technologies he shouldn't have known about. Rinehart wrote that the patient's knowledge of future electronics was particularly disturbing. He described transistor technology in 1947, years before transistors reached military applications. He sketched circuits that Navy engineers later confirmed would function, though they used principles not yet incorporated into standard designs. When Rinehart suggested these might be fantasies or lucky guesses, the patient produced burns on his arms and chest, unusual scarring that medical examination could explain. The burns became a pattern in other cases. 2 other men treated at different facilities showed similar marks. Medical reports described them as inconsistent with known energy sources, not radiation burns, not chemical burns, not thermal damage matching any conventional cause. One physician noted that the cellular damage pattern suggested exposure to extremely powerful electromagnetic fields, but at intensities that should have been lethal. The men were injured but alive, scarred but functional. More disturbing was the aging discrepancy. In at least one documented case, a patient's physiological markers didn't match his documented age. Dr. Rinehart noted this explicitly in his journals. The man claiming to be 28 showed cellular and skeletal indicators suggesting he was 24 or 25, 4 years younger than his birth certificate indicated. Rinehart considered explanations, falsified documents, misidentification, but the patient had fingerprints on file from his enlistment, and they matched same person, wrong age. As if he had skipped forward through time, missing years of biological aging, while those years passed for everyone else. The Navy's response to these cases was consistent. The men were suffering from combat trauma, delusional disorders, or elaborate fabrications. There was no USS Eldridge experiment, no electromagnetic invisibility test, no temporal displacement. The official denials were absolute, and yet declassified documents from the 1940s confirm something interesting. The Navy was conducting electromagnetic experiments during that period. Research into degassing, using electromagnetic fields to make ships invisible to magnetic mines. Some of this research took place at the Philadelphia Naval Yard. Some involved destroyer escorts. The Navy hasn't disputed this. What they dispute is that any experiment produced the dramatic effects described by the alleged survivors. Multiple researchers have noted inconsistencies in the Navy's denials. Ship location records show gaps. Crew assignment documents contain unexplained redactions. The Eldridge S official log for certain dates in late 1943 is missing from archives, replaced with a note indicating the pages were damaged and removed. When journalists have requested these records through FOIA, they've been told the documents were lost or destroyed under routine procedures. The medical records remain more troubling than the official denials. Dr. Rinehart wasn't a conspiracy theorist or fringe researcher. He was a career military psychiatrist with top-level clearance. His private journals weren't written for publication, but as personal professional records. He documented what he observed without embellishment or speculation, and what he observed could be explained by conventional trauma or delusion. Other naval medical personnel from that era reported similar cases, though most didn't document them as carefully as Rinehart. Sailors presenting with temporal disorientation, unexplainable burns, age discrepancies, memory of future events. These reports appeared in different facilities, treated by different doctors who had no contact with each other. The pattern existed across multiple independent sources. Perhaps all of these men were elaborate hoaxes, coordinating false medical symptoms and falsified knowledge of future technology. Perhaps the burns were self-inflicted, the age discrepancies were document errors, the memories of future events were coincidental lucky guesses. Perhaps every anomaly has a conventional explanation that just hasn't been documented. Or perhaps something happened aboard a destroyer escort in 1943 that official records decided to erase. Something that left survivors scattered across naval hospitals for years afterward, trying to explain symptoms that medicine could categorize and experiences that physics said were impossible. The military can classify experiments, deny operations, seal records, but they can easily erase medical documentation from multiple independent facilities. Those records remain, and they describe something that shouldn't exist. Frank was off duty that Saturday in 1996, doing something completely ordinary, shopping with his wife in Liverpool's city centre. They separated briefly. She went into a bookstore while he headed to a music shop down Bold Street, one of the city's oldest thoroughfares. He walked perhaps 50 meters and then everything changed. The air felt different first, cooler, heavier, like stepping from air conditioning into summer humidity, except reversed. The sounds changed, traffic noise faded, replaced by something quieter, older. Frank looked up and stopped walking. The stores around him were wrong. The modern shop fronts he'd seen moments ago had vanished, replaced by businesses with hand-painted signs and window displays that looked decades out of place. A women's clothing boutique he'd never seen before, a tobacco shop with a name he didn't recognize. The people were wrong too. Their clothing looked vintage, not costumes, but genuine period attire, worn naturally, unself-consciously. Women in knee-length dresses and heeled shoes from another era, men in suits with wide lapels. A van drove past that looked like something from a museum, painted in a style and color scheme that hadn't been used since the 1950s. Frank was a police officer, trained to observe details and maintain composure in strange situations. He stood there trying to process what he was seeing. He walked further down the street. The buildings themselves seemed somehow cleaner, less weathered. A store he'd passed 100 times bore a different name, Cripps, a women's clothing shop that he later discovered had closed in the early 1970s. He watched people enter and exit. They weren't acting like it was anything unusual. To them, this was normal. He was the anomaly. The experience lasted several minutes. Then, just as suddenly it ended, a blink, a moment of disorientation, and he was back. Modern Bold Street, contemporary shops, people in current fashion. The van was gone. Cripps was gone. He stood there feeling like he desurfaced from deep water, disoriented and slightly nauseous. Frank reported the experience because he thought he might have had a medical episode, a stroke, a seizure, something that explained the hallucination. Medical examinations found nothing. No neurological abnormalities, no indication of temporal lobe epilepsy or dissociative disorders. He was physically healthy, but his description was so specific and disturbing that it was documented and, eventually, investigated by researchers interested in temporal anomalies. A street in Liverpool swallows people into the past. It has happened dozens of times. Witnesses have given details they shouldn't know, and it is still happening. What made Frank's case extraordinary wasn't just the experience itself, but what investigators discovered afterward. He wasn't alone. Multiple people had reported similar experiences on Bold Street, though most hadn't officially documented them. When researchers began interviewing witnesses, patterns emerged. The same location, similar descriptions of sudden environmental shifts, consistent details about the time periods people seemed to enter. Most frequently, the 1950s and 1960s, occasionally earlier. Some experiences provided specific information that they shouldn't have known. Store names that researchers confirmed had existed during the relevant decades, but had closed long before the experiencers were old enough to remember them. One woman described a café interior in precise detail, including wall decorations and menu items that matched historical photographs discovered in city archives. Photographs she never seen. Psychological explanations exist. Temporal lobe epilepsy can create vivid hallucinations of past scenes. False memory syndrome could explain why people believe they saw things that match historical records. The environment of an old street might trigger dissociative episodes where the brain fills in appropriate details from subconscious knowledge absorbed through old photographs or films. But some details resist easy dismissal. Several experiences claim to have brought objects back: old coins, paper tickets, receipts with dates past. None have been conclusively authenticated. The coins could be collector items. The tickets could be reproductions. But their existence raises questions about how to definitively prove something came from a different time period when that object type existed in both periods. The concept of thin places appears in cultures worldwide, locations where the boundary between different states of reality becomes porous. Often these are associated with spiritual realms or other dimensions. But some researchers have wondered whether certain locations might be thin temporally rather than spiritually. Places where the barrier between different time periods somehow weakens, allowing brief crossings or perceptions across temporal boundaries. Bold Street isn't unique. Similar recurring reports come from historic districts in Edinburgh, certain streets in Paris, sections of Rome's Old City, parts of Prague's medieval quarter. Always old places, always specific locations within those cities rather than the entire area. Always describing transitions into the past rather than the future. The pattern suggests either a genuine phenomenon linked to certain geographic locations, or environmental triggers that produce a very specific type of collective hallucination. Both possibilities remain on the table. The evidence doesn't definitively prove either. What is clear is that people continue reporting these experiences, continue providing details that sometimes match historical records, and continue struggling to explain what they witnessed. But anecdotal cases, however compelling, aren't scientific proof. They're stories, data points, mysteries. To understand whether time can actually fracture, we need to look somewhere else. Not at streets or ships or travelers from nowhere, but at controlled laboratories where scientists have attempted something extraordinary, measuring whether time itself can be manipulated. There is a laboratory experiment that is being conducted hundreds of times across multiple continents. It uses equipment you'd find in any university physics department. Lasers, beam splitters, detectors, nothing exotic. The setup is straightforward, the results are impossible. In laboratories worldwide, scientists are measuring something impossible, effects happening before their causes. The future is reaching backward, and government agencies wanted to know if humans could do it too. The experiment is called the delayed choice, quantum eraser. The name sounds technical, but what it measures is disturbingly simple. Scientists fire individual photons, particles of light, through a system that records how they behave. The photons can take one of two paths. Normally, if you measure which path a photon takes, it behaves like a particle, creating one pattern on a detector. If you don't measure which path it takes, it behaves like a wave, creating a different pattern, an interference pattern showing it somehow traveled both paths simultaneously. This quantum weirdness has been known since the early 20th century. What makes the delayed choice version disturbing is the timing. In this experiment, scientists make their decision about whether to measure the photon's path after the photon has already hit the detector, after the pattern should already be determined, after the past should be sealed. Here is what happens. The photon hits the detector first. This creates the initial pattern. But downstream after this detection, scientists can choose to erase the information about which path the photon took. This choice happens microseconds after the photon's interaction with the detector. It happens in what anyone would call the photon's future. And when scientists make that future choice to erase the path information, the pattern that already formed at the detector changes. Not the future pattern, the past pattern, the one that was created before the choice was made. The photon's behavior in the past depends on a measurement decision made in its future. This has been verified in laboratories at the University of Vienna, the University of Maryland, Seoul National University, and multiple institutions in China. The results are published in peer-reviewed journals. They're repeatable. Any physics lab with the right equipment can demonstrate this effect. It is not controversial that the experiment works. What is controversial is what it means. Some physicists argue this isn't really time travel. It is just revealing that our intuitive understanding of causality breaks down at quantum scales. They propose that quantum systems exist in superposition states until all measurements are complete, regardless of when those measurements happen in our subjective timeline. The photon doesn't know what happened until the entire experimental setup is resolved, even if that resolution occurs after the initial detection. Other physicists interpret the results more directly. Information is traveling backward in time. The future measurement is reaching into the past and changing what occurred. Not metaphorically. Actually, the mathematics describing this backward causation works perfectly well. The equations don't distinguish between time flowing forward and backward. They re-time, symmetric. If information can flow forward from cause to effect, perhaps under quantum conditions it can flow backward from effect to cause. The implications make most physicists uncomfortable. If effects can precede causes even in controlled laboratory conditions, then the foundation of causality, the principle that causes always come before effects, is in absolute. It is not just that the future is uncertain, it is that the past might be less fixed than we assume, susceptible to influence from events that haven't happened yet from our perspective. This is where classified research enters the picture. In 2014, DARPA, the Defense Advanced Research Projects Agency, the military's division for investigating breakthrough technologies, funded a research program called Precognitive Sentient Sensing. The objective was explicit: explore whether human perception and decision making might be influenced by future events through retrocausal mechanisms. Could trained operators detect threats before those threats manifested? Could decision-making be enhanced by unconsciously accessing information from the immediate future? The program's initial phase was public. Research proposals were solicited. Scientists with legitimate credentials from respected institutions submitted applications. Then the program went quiet. No results were published. No follow-up announcements appeared. When researchers tried to obtain information through Freedom of Information requests, they were told the findings were classified for national security reasons. Why classify research into whether humans can sense future events? Either the research found nothing, in which case classification seems unnecessary, or it found something, and that something was significant enough to restrict from public knowledge. Retrocausality at the quantum level is proven. Photons demonstrably respond to future measurements. The question DARPA asked was whether this principle scales, whether larger systems, complex systems, biological systems might exhibit similar temporal anomalies, whether human consciousness might have some capacity to perceive or interact with events outside normal temporal sequence. The fact that the research was classified suggests the answer wasn't simple. Perhaps they discovered nothing conclusive but something interesting enough to continue investigating privately. Perhaps they found evidence that human temporal perception operates differently than we assume. Or perhaps they found something that raised questions too disturbing to address publicly. Quantum mechanics has already shown that time doesn't work the way common sense suggests. Now, the question becomes whether these quantum temporal oddities remain confined to subatomic particles, or whether they extend to the world we inhabit. Every moment of your life, entropy increases, your coffee cools, buildings crumble, batteries drain. The universe moves from order toward disorder, from structure toward chaos. This isn't just observation, it is the second law of thermodynamics, one of the most fundamental principles in physics. It defines time. S arrow. The past is the direction of lower entropy, the future is the direction of higher entropy. This arrow has never been reversed for any macroscopic system in the history of observation until 2019, when Russian scientists claimed they had done exactly that. In 2019, Russian scientists ran time backward in a quantum computer. It worked. The question isn't whether they did it. It is why governments are classifying similar research. Researchers at Moscow's Institute of Physics and Technology published their findings in Scientific Reports, a peer-reviewed journal. They'd taken an electron in a quantum computer and run time backward for it, if only for a fraction of a second. The experiment was elegant. They started with an electron in a known state, then allowed it to evolve naturally. Like a drop of ink diffusing through water, the electron's quantum state spread out, becoming more disordered, more uncertain. Entropy increased. Time, S arrow pointed forward. Then they intervened. Using precisely calibrated microwave pulses, they reversed the electron's evolution. The quantum state, UN, scattered itself, moving from disorder back toward order, from uncertainty back toward its original condition. Like watching that drop of ink gather itself back together, pulling out of the water, reforming into a concentrated drop, entropy decreased. The electron experienced time flowing backward. Critics were immediate and vocal. This wasn't true time reversal. They argued just a clever manipulation of quantum states. The researchers had essentially rewound the electron like rewinding a video. They hadn't violated causality or reversed time for the universe, just for one quantum system in an artificial environment. The second law of thermodynamics applies to closed systems, and the quantum computer was closed. It had external energy input controlling the reversal. The Russian team didn't dispute these objections, but they maintained their conclusion. They had demonstrated that quantum systems can be made to violate the intuitive direction of time, S arrow. Whether you call it true time reversal or not, an electron had moved from higher entropy to lower entropy, from disorder to order, from later quantum states to earlier ones. Something had flowed backward through time, and they weren't the only ones observing temporal oddities in controlled systems. In 2017, researchers at the Argonne National Laboratory observed something equally strange. They were studying the behavior of gas molecules in a confined space, expecting to see the standard progression, molecules starting ordered, then scattering randomly as entropy increased. What they observed instead were brief moments when entropy spontaneously decreased. Small clusters of molecules spontaneously organized themselves into lower entropy configurations without external cause. These violations of time's expected direction were brief, lasting microseconds, and limited to microscopic scales. But they were measurable, they were repeatable. They suggested that the arrow of time, while statistically dominant, isn't absolutely enforced at quantum scales. Under certain conditions, time can locally flow backward or sideways, or simply stop following the rules we assume are universal. The second law of thermodynamics is statistical, not absolute. It says entropy tends to increase, not that it must always increase. For macroscopic systems, anything larger than molecules, the statistical probability of entropy decreasing is so astronomically low that it never happens in practice. But for small quantum systems, the probabilities shift, temporary reversals become possible, even if still rare. This raises questions that extend beyond physics. Several researchers have proposed that consciousness might be deeply connected to time, arrow. Perhaps our subjective experience of time flowing forward emerges from increasing entropy in our neural processes. Perhaps the reason we remember the past but not the future is fundamentally thermodynamic rather than temporal. And if consciousness depends on entropy, what happens in systems where entropy temporarily reverses? Here is where published research transitions into classified territory. Multiple physicists have proposed experiments testing whether conscious observation affects temporal processes, not just revealing them, as in quantum measurement, but actually influencing which direction time flows for observed systems. These proposals received funding from defense and intelligence agencies. Initial studies showed what researchers carefully described as statistically significant anomalies in temporal perception during low entropy fluctuations. Then the publications stopped. The researchers moved to classified projects. When asked about results, they mentioned non-disclosure agreements. The research continues somewhere, but its findings remain hidden behind security classifications. The pattern repeats. Open research demonstrates temporal anomalies at quantum scales, proposes extensions to biological or consciousness-related systems, receives government funding, then disappears into classification. Either these extensions produce nothing interesting, making classification pointless, or they produce something interesting enough to hide. Quantum computers have run time backward. Gas molecules have spontaneously reduced entropy. The arrow of time can be locally violated in controlled conditions. These are established facts. What remains uncertain is whether these quantum temporal anomalies extend beyond photons and electrons, whether larger systems, biological systems, conscious systems might exhibit similar capabilities, and whether anyone investigating those questions is allowed to tell us what they found. The experiment seems simple. You sit in a quiet room facing a computer screen. Sensors monitor your body, heart rate, skin conductance, pupil dilation. The computer will show you images randomly selected from a database. Some images are calm, nature scenes, neutral faces, geometric patterns. Others are emotionally provocative, violence, eroticism, disturbing imagery designed to trigger strong physiological reactions. The computer hasn't selected the next image yet. The algorithm will choose randomly in 5 seconds. You are sitting there waiting, looking at a blank screen, and the sensors are recording your baseline physiology. Nothing has happened. There is nothing to react to, and then your body reacts anyway. Your body knows what is going to happen 5 seconds before it happens. This has been measured in over 50 experiments. Intelligence agencies wanted to know if they could train people to do it better. Dr. Dean Radin, a researcher who has held positions at Princeton University and the Institute of Noetic Sciences, began conducting these experiments in the 1990s. The protocol was designed specifically to eliminate conventional explanations. The image selection was truly random, determined by quantum processes or radioactive decay, methods with no predictable pattern. Participants could know what was coming through any normal sensory channel. They were isolated from any information about the upcoming image, yet their bodies knew. Seconds before the computer selected an emotionally charged image, participants showed physiological spikes, increased heart rate, heightened skin conductance, dilated pupils. The response occurred before the cause. Their bodies were reacting to something that hadn't happened yet from any conventional timeline perspective. The effect was small but consistent. Across individual trials, the anticipatory response was subtle enough to be invisible to the participant, but across dozens of participants and hundreds of trials, the statistical pattern became undeniable. Meta-analyses examining thousands of sessions showed effect sizes that exceeded chance by margins too large to dismiss as coincidence or experimental artifact. Critics argued the findings must be flawed. Perhaps subtle cues were leaking information. Perhaps the randomization wasn't truly random. Perhaps physiological noise was being mistaken for signal. Researchers addressed each objection. They used quantum random number generators. They conducted double-blind protocols where even the experimenters didn't know what image was coming. They eliminated potential information channels. The effect persisted. Mainstream science responded with fierce skepticism. The results challenged fundamental assumptions about causality and time. If human physiology can respond to future events, that suggests either information traveling backward in time or consciousness existing partially outside linear temporal flow. Both possibilities seemed impossible, so the experiments must be wrong regardless of their apparent rigor. But the experiments kept replicating. Research teams in the Netherlands, in Scotland, at Cornell University, at the University of Amsterdam, independent laboratories following similar protocols produced similar results. Not every study found the effect, but meta-analyses showed the positive findings outweighed chance expectations significantly. Something was happening that standard models of consciousness and time could easily accommodate. The proposed explanations varied. Some researchers suggested quantum entanglement between decision-making moments, that the present moment might be quantum, mechanically connected to near-future moments in ways that allow information exchange. Others proposed that consciousness doesn't experience time purely linearly, that our awareness might extend slightly forward and backward around the present moment, like a temporal spotlight illuminating, not just now but a few seconds on either side. Then intelligence agencies became interested, not publicly, but through quiet funding channels. If humans could unconsciously detect future events even seconds in advance that had obvious applications, threat detection, enhanced situational awareness, operators who could sense danger before it manifested through conventional cues. The public research established that the effect existed under laboratory conditions. The classified research explored whether it could be enhanced, trained, weaponized, whether certain individuals showed stronger presentiment effects, whether specific training protocols could amplify the natural tendency, whether the few seconds of foresight demonstrated in academic labs could be extended or made more reliable. Those findings remain classified. What is known publicly is that presentiment research received funding from defense and intelligence sources through the early 2000s. Then publication of results became sparse. Either the research concluded the effect wasn't useful for operational purposes, or it discovered something useful enough to keep secret. What the public studies demonstrated is disturbing enough. Human physiology responds to future events before those events occur, not through any known sensory mechanism, not through logical prediction or pattern recognition, but through some connection between consciousness and time that conventional neuroscience doesn't acknowledge. The body knows something the mind does. It responds to futures that haven't arrived, and somewhere in classified programs, researchers explored what that means and whether it could be harnessed. But all of this, the quantum experiments, the time reversal, the presentiment effects, raises the question that has troubled physicists since Einstein first opened these doors. If time travel is possible in theory, demonstrated in laboratories potentially accessible to human consciousness, then where are the time travelers? If the future develops time travel, where are the tourists from tomorrow? This question has paralyzed the discussion for decades. It seems like the ultimate proof that time travel must be impossible, despite all the theoretical and experimental evidence. But that conclusion assumes something about time travel that might be wrong. The objection is older than most theories about time travel. It is simple, elegant, and seems absolutely fatal to the entire concept. You travel back to 1920 and prevent your grandfather from meeting your grandmother. They never marry. Your parent is never born. You are never born, but if you are never born, you can travel back to prevent their meeting, so they do meet. So you are born, so you do travel back. The loop has no exit, logic collapses, therefore time travel must be impossible. Physicists call this the grandfather paradox, and for decades it was treated as the definitive proof that backward time travel could exist in any meaningful form. If the mathematics allowed it, if the equations permitted closed timelike curves, reality would simply find a way to prevent them from forming. The universe could permit paradoxes, therefore it could permit time travel. But then physicists started asking a different question. Not whether the paradox makes time travel impossible, But whether time travel makes the paradox impossible? Every physicist knows you can change the past. But what if you already did? What if every time travel attempt that failed was actually succeeding exactly as history requires? The Novikov self-consistency principle, proposed by Russian physicist Igor Novikov in the 1980s, offers an elegant solution. The principle states that if time travel to the past is possible, then only self-consistent timelines can occur. Not because some cosmic force prevents paradoxes, but because paradoxes are logically impossible. They contradictions that reality simply can instantiate. Here is how it works in practice. You travel back to 1920 intending to prevent your grandparents from meeting. You arrive successfully. You locate your grandfather. You prepare to intervene, and then something stops you. Perhaps you miss your chance because of heavy traffic. Perhaps you get cold feet at the crucial moment. Perhaps your grandfather mistakes you for someone else, and your intervention accidentally causes him to go to the party where he meets your grandmother. Perhaps you succeed in preventing their planned meeting, but they encounter each other by chance the next day instead. The principle does specify what stops you. It only requires that something does. The universe does need special paradox, prevention police. It just needs probability chaos and the infinite complexity of cause and effect. In a self-consistent timeline, attempts to create paradoxes fail through perfectly ordinary circumstances. This sounds like mysticism, but it is actually rigorous logic. If time travel exists and creates a single consistent timeline, then that timeline must include all time travel that occurs within it. Your attempt to prevent your grandparents' meeting is already part of history. It happened, and history shows they met anyway. Your time travel attempt didn't change the past. It was always part of the past that produced the present from which you traveled. Consider what this means. Perhaps every failed time travel attempt was actually successful, but success meant maintaining historical consistency rather than changing it. Perhaps throughout history, people have traveled back trying to alter events, and their attempts became part of the tapestry of causes that produced exactly the history we know. The assassination that was prevented by a jammed gun. The meeting that almost didn't happen, but did because someone took a different route home. The disaster that was narrowly averted by a series of improbable coincidences. What looks like luck or chance from one perspective might be consistency requirements from a temporal perspective. The Novikov principle doesn't make the past immutable in some mystical sense. It makes the past immutable because it is already complete. Already includes all the time travel that ever occurs. You can't change history because your time travel is already part of history. You're not editing a document, you're reading one that was always written in a particular way. This creates a strange situation for anyone attempting to travel to the past. You can't change anything, but not because you're forbidden. You can't change anything because anything you do was what always happened. Free will remains intact. You can choose your actions, but the outcomes of your actions are constrained by the requirement that they lead to the present from which you departed. Some physicists find this solution satisfying. It preserves causality, prevents paradoxes, and allows time travel without requiring new physics beyond general relativity. Others find it disturbing because it implies a kind of predetermined consistency. If your time travel is already part of history, then in some sense your future actions are already determined. Not by physical law removing your choices, but by logical consistency, requiring that your choices produce particular outcomes. And here is the uncomfortable question this raises. If the Novikov principle is correct, if self-consistency is enforced, does that mean the future is fixed? Are we trapped in a predetermined timeline where everything has already happened in some temporal sense, and we're just experiencing it sequentially? Or is there another possibility, one even stranger than self-consistent timelines? The Novikov principle solves paradoxes by making history self-consistent. But there is another solution, one that comes from quantum mechanics rather than relativity. It is stranger than self-consistency, and in some ways more disturbing. It says you can change the past, you just can go home. The many worlds interpretation of quantum mechanics proposes that every quantum event causes reality to branch. When a particle can go left or right, both happen. Reality splits into two branches, one where it went left and one where it went right. This is metaphorical. It is a literal interpretation of quantum mathematics that takes the equations at face value without adding collapse mechanisms. Most people encounter many worlds as abstract philosophy. But when you combine it with time travel, something unexpected happens. The paradoxes disappear. Imagine traveling back to 1920 to prevent your grandparents from meeting. In the many worlds model, the moment you arrive in 1920, you are not in your original timeline anymore. You've entered a branch, a parallel universe, nearly identical to the one you left, but not quite the same. When you prevent your grandparents from meeting, you alter this branch's future. In this timeline, you are never born, but you still exist because you came from a different branch where your grandparents did meet and you were born. No paradox, no logical contradiction. Just two branches, one where you exist and travel back, another where your intervention creates a different history. You can change the past because you are not really changing your past. You are creating an alternate timeline. You can change the past. You just can't go home because the moment you arrive, you are not in your universe anymore. You are somewhere else, somewhere similar, but forever different. This solution is elegant. Time travel doesn't violate causality because cause and effect remain intact within each branch. You were born in branch A, traveled to branch B, past, and created branch C, future. Everything follows a consistent causal chain. The grandfather paradox evaporates because you killing your grandfather doesn't prevent your birth. It prevents the birth of a different version of you in a different timeline. But here is the disturbing implication. If this model is correct, time travel is a one-way exile. You can return to your original timeline because you never left it. You jumped to a parallel branch. Every action you take in the past creates new branches, new timelines splitting off endlessly. The world you came from continues existing without you. You are stranded in an alternate reality that resembles home but will never be home. Some physicists find this more troubling than paradoxes. At least paradoxes make time travel cleanly impossible. The many world solution makes it possible, but existentially devastating. Every time traveler becomes permanently displaced, cut off from everyone they knew, everything they cared about. Success is indistinguishable from permanent exile. The many worlds interpretation isn't just speculation. Evidence supports it from quantum experiments. The double-slit experiment shows particles behaving as if they interact with versions of themselves in other branches. Quantum computers exploit superposition, states existing in multiple configurations simultaneously, suggesting these parallel states are real. Recent experiments demonstrate quantum systems maintaining contradictory properties until measurement, behaving exactly as many worlds predicts. The interpretation remains controversial, not because it is disproven, but because it is extravagant. It multiplies universes endlessly. Most physicists find this philosophically uncomfortable, even while acknowledging the mathematics works cleanly. But if many worlds is correct, if reality constantly branches, then time travel becomes paradox. Free. The price is knowing you can never return. You can visit any moment in history, change anything you want, and the only cost is losing your universe forever. Which raises the question that has haunted this entire investigation. If time travel is possible through Novikov consistency, or many worlds branching, if the paradoxes are solved, if the physics permits it, then where are the time travelers? Where are the tourists from the future? The paradoxes can be solved. The physics allows it. The mathematics work. Time travel appears possible through multiple theoretical routes, wormholes, rotating universes, quantum mechanics, even consciousness accessing temporal information. So where are they? If humanity develops time travel at any point in the future, where are the visitors from tomorrow? This silence seems like the strongest evidence against time travel. If it is possible, if it is ever achieved, then logically our present should be crowded with temporal tourists, future historians, and people fleeing their eras. The absence of obvious time travelers suggests either the technology is never developed, or something prevents them from visiting. But absence of evidence isn't evidence of absence, and the explanations for their silence are as intriguing as their presence would be. If time machines exist in the future, why haven't tourists appeared in our present, unless they have? Unless they're reading this right now. Unless you're one of them and don't remember. Maybe they're here but undetectable. Time travel might require methods so subtle that travelers leave no observable trace. Perhaps they exist slightly out of phase with our timeline, perceiving us while remaining invisible. Perhaps their technology allows them to observe without interacting, watching history unfold without disturbing it. We wouldn't see them because seeing them is impossible, given how temporal displacement actually works. Maybe they're prohibited. Future civilizations might have developed strict regulations preventing interference with the past. Temporal tourism could be illegal, enforced with technology that tracks and prevents unauthorized trips. Perhaps humanity discovers time travel and immediately recognizes its danger, establishing global treaties that restrict its use to specific authorized purposes, research, monitoring, but never casual interference. Maybe time travel is one way. The physics might permit traveling backward but not forward. Every time traveler becomes permanently stranded in their destination, unable to return and report their success. The future develops time travel, people depart for the past, and they simply vanish from the future's perspective. They're here, scattered throughout history, but indistinguishable from natives because they can never leave. Maybe we're early. Some theories suggest time travel can only reach back to the moment the first time machine is activated. You can't visit before the technology exists because there is no receiver in the past. If true, then everything before the invention of time travel is inaccessible to future travelers. We're living in the pre-time travel era, and when the first machine activates, history will suddenly become navigable from that moment forward. Maybe they erase their traces. Advanced temporal technology might include methods for editing causality itself. Time travelers could visit, interact, change things, then use technology to remove evidence of their interference. The timeline self-corrects or is corrected artificially. We don't see them because they've ensured we can't see them, cleaning up after themselves with tools we can't imagine. Maybe we can't recognize them. Time travelers might walk among us using technology that makes them appear ordinary perfect disguises, genetic modification, memory implants that create false histories. Or perhaps time travel doesn't look like we expect, no dramatic arrivals in machines. Just consciousness shifts, quantum jumping between timelines, methods so subtle they're invisible unless you know what to look for. Or maybe, and this is the most disturbing possibility, or timeline is one where time travel is discovered and immediately suppressed. Perhaps humanity develops temporal technology, recognizes it as an existential threat, and classifies everything related to it. The research continues in secret. The technology exists but is controlled by entities that prevent its proliferation. In this scenario, time travel is real, operational, and completely hidden from public awareness. Each explanation suggests something different about reality, but they all acknowledge the same uncomfortable fact. The silence from the future isn't proof that time travel is impossible. It is evidence that requires explanation, and some of those explanations are stranger than time travel itself. The theoretical problems are solved. The physics permits it. The mathematics work, but theory is one thing, reality is another. And if someone is actually manipulating time right now, they're leaving traces, small anomalies, patterns that don't quite fit, evidence hidden in plain sight for anyone willing to look closely at the world around them. There is a memory thousands of people share. They remember watching news coverage in the 1980s about Nelson Mandela's death in a South African prison. They remember the funeral. They remember the mourning. Some remember specific details, the speeches, the reactions, the way the story unfolded across television screens worldwide. The memory is vivid, detailed, and completely wrong. Nelson Mandela didn't die in prison in the 1980s. He was released in 1990, became president of South Africa, and died in 2013. These thousands of people don't have vague recollections. They have identical, specific false memories of events that never occurred. Millions of people remember a different past. Not vague memories, specific, detailed, identical false memories. Psychologists can fully explain it. Some physicists think they can. The phenomenon is called the Mandela effect, named after that widely shared false memory. But Mandela's death is just one example. People remember the Berenstain Bears, children's books about a family of bears, except the name was always Berenstain. Thousands of people remember the evil queen in Snow White saying, "Mirror, mirror on the wall," she says, "magic mirror." People remember the Monopoly man having a monocle. He doesn't. Chartreuse is remembered as red or burgundy. It is actually a yellowish, green. Mainstream psychology has explanations. False memory formation occurs through suggestion and social reinforcement. People hear others describe a memory incorrectly, absorb that version, and their own memory shifts to match. The internet amplifies this. One person posts a false memory, others read it and unconsciously adopt it, creating the illusion of independent, identical memories. Our brains are remarkably unreliable, constantly reconstructing rather than replaying the past. These explanations work for many cases, but some aspects resist comfortable dismissal. Why do geographically separated people develop identical, detailed false memories before internet communication could spread them? Why do these memories cluster around specific details rather than being randomly distributed? People don't collectively misremember whether France exists or what color the sky is. They misremember specific brand names, specific quotes, specific details that seem almost arbitrary in their specificity. And then there are the documented cases. People who find old journals with entries referencing Berenstain Bears spelled the way they remember, not the way it currently is. Photographs that seem to show details matching the false memory rather than current reality. Evidence that appears to support the memory only to find that official records contradict it. Skeptics argue these pieces of evidence are themselves misremembered or misidentified, but they keep appearing. The controversial hypothesis emerged from an unexpected place: quantum physics. Some researchers have proposed that Mandela effects might be evidence of timeline shifts. Not that history was rewritten, but that human consciousness occasionally jumps between adjacent parallel timelines, branches of reality so similar that the shift goes unnoticed, except for small inconsistent details. In the many worlds interpretation, every quantum event creates branching timelines. Most branches are radically different, but some are nearly identical, differing only in minor details. A brand name spelled slightly differently. A movie quote phrased one way versus another. If consciousness can occasionally slip between these adjacent branches, perhaps during sleep, during moments of quantum decoherence in neural processes, during transitions we don't notice, then people would remember one timeline while living in another. This sounds absurd until you remember that quantum consciousness theories are serious research areas, that experiments show quantum effects in biological systems, that some physicists have proposed testing whether macroscopic systems, including brains, can maintain quantum superposition across timeline branches. The hypothesis remains speculative. Most scientists dismiss it, but a few take it seriously enough to design experiments. Tests measuring whether people experiencing Mandela effects show unusual quantum signatures in their neural activity. Studies examining whether these false memories correlate with specific geographic locations or temporal windows. Research that is ongoing, unpublished, and controversial enough that journals hesitate to accept it. Meanwhile, the experiences continue. People discover their memories don't match consensus reality. Not vague hunches, but specific certainties that turn out to be wrong. And they find others, sometimes thousands of others, who remember the same incorrect version in the same incorrect detail. Perhaps these are all conventional false memories, spread through social reinforcement and cognitive bias. Perhaps human memory is simply too unreliable to trust. Or perhaps some people remember a different past because they experienced a different past, and the timelines they're remembering still exist somewhere in the quantum multiverse. The question isn't settled, but it is worth examining your own memories. Those things you're absolutely certain about, despite everyone saying you're wrong. Those details that feel too specific to be random errors. Maybe you're just misremembering. Or maybe you're remembering correctly, just not remembering this timeline. In 1901, sponge divers working off the Greek island of Antikythera discovered a Roman shipwreck from approximately 60 BCE. Among the artifacts recovered was a corroded lump of bronze that seemed unremarkable. For decades it sat in storage at the National Archaeological Museum in Athens. Then, in the 1950s, a researcher noticed something strange. The corrosion had split apart, revealing gears inside. Not simple gears. Precision mechanical components arranged in a complex system. As researchers carefully reconstructed the device using X-ray imaging and modern scanning technology, they discovered something that shouldn't have existed 2,000 years ago, an astronomical calculator of stunning sophistication. A 200-year-old computer was pulled from a shipwreck. It predicted eclipses. Historians still can't explain who built it or why, unless someone from our future left it there. The Antikythera mechanism contained at least 30 bronze gears with triangular teeth, arranged to calculate the positions of the sun, moon, and planets. It predicted solar and lunar eclipses years in advance. It tracked the ancient Olympic Games cycle. The level of miniaturization and precision rivals clockwork from the 1700s technology that was supposed to exist for another millennium and a half after the shipwreck. Historians have proposed explanations. Perhaps ancient Greek engineering was more advanced than we realized. Perhaps knowledge was lost during the collapse of classical civilization. These explanations work if you accept that a singular genius created this device using techniques that left no trace in any other ancient artifact or text. Techniques that humanity then completely forgot and had to reinvent over 1,000 years later. Or there is another explanation, one that archaeology doesn't want to consider. The Baghdad battery presents a similar puzzle. In 1936, workers discovered clay jars in a village near Baghdad, dated to approximately 200 BCE. Inside each jar, a copper cylinder, an iron rod, and traces of an acidic substance. When researchers reconstructed these jars using the original materials, they produced electrical voltage, roughly half a volt, enough to power small devices or create electroplating effects. Conventional explanations suggest they were used for electroplating gold onto silver, though no archaeological evidence of such practice exists in that time period. Or perhaps they were just storage vessels and the electrical properties are coincidental, but the design is functional. It produces electricity, and it shouldn't exist in ancient Mesopotamia. Then there is the aluminum wedge of Aiud. In 1973, workers excavating near the Romanian city of Aiud found a metallic wedge buried alongside mastodon bones. Geological analysis dated the layer to approximately 200,000 years ago. The wedge was sent for analysis. It was aluminum. Aluminum wasn't isolated by humans until 1825. The industrial production process was developed in the 1880s. Before that, aluminum was rarer and more expensive than gold because separating it from bauxite ore requires electrolysis and significant energy input. It doesn't occur naturally in metallic form. The wedge was tested multiple times. The results confirmed it was an aluminum alloy with traces of copper, silicon, zinc, lead, and other elements. The composition matches modern aluminum alloys. The object showed signs of machine tooling. It was found in strata dated to 200,000 years before modern humans developed metalworking. Scientific journals refused to publish the findings, not because the tests were flawed, they weren't, but because the implications were too problematic. If the dating is correct, then either the wedge was planted as a hoax or something impossible happened. Most researchers assume hoax and move on, but the pattern exists across multiple cases. Objects that shouldn't exist where they're found, technology that appears before it should be possible. Each case has potential conventional explanations if viewed individually. Collectively, they suggest something stranger. What if these aren't anomalies but contamination? Future technology accidentally or deliberately left in the past. time travelers losing equipment, temporal experiments that deposit objects in wrong eras, deliberate placements for purposes we can't discern. The Antikythera mechanism could be coincidental genius. The Baghdad battery could be misinterpreted function. The aluminum wedge could be elaborate fraud. But when objects consistently appear that mainstream archaeology struggles to explain, that have technology displaced by centuries or millennia, that force researchers to propose unlikely coincidences rather than acknowledge the simpler but impossible explanation, perhaps the pattern itself is the evidence. Perhaps history contains artifacts from its own future, objects left behind by travelers who came backward to observe or interfere. Physical proof that time travel isn't just theoretical, but has already occurred, already contaminated our timeline with traces of technology that don't belong. And if these ancient anomalies exist, if temporal interference occurred in the past, there is no reason to think it stopped. Perhaps it is still happening. Perhaps modern times contain their own temporal contamination, anomalies we're living through right now. Photographs are supposed to be permanent records. Light hits film or sensor, creates an image, and that image becomes fixed, a moment captured, a slice of time preserved exactly as it occurred. We trust photographs because they mechanical, objective, immune to the malleability of memory. When your memory conflicts with a photograph, the photograph is right always, unless the photograph changes. In 1995, a family in Oregon took photos at a birthday party. Standard disposable camera. Film processed at a local pharmacy, prints stored in an album. Years later, looking through old photos, they noticed something impossible. In one image, clearly visible on someone's wrist, was what appeared to be a smartwatch. Not a regular watch, a rectangular device with a digital display resembling an Apple Watch or similar modern technology. The photograph was from 1995. The first smartwatch would be released until 2013. A photograph from 1995 shows technology that didn't exist yet. Forensic experts confirmed it wasn't faked. The people in the photo don't remember the object being there. It appeared later. Somehow, the family had the photograph examined. Forensic analysts confirmed it was genuine film from the 1990s, properly processed, showing no signs of digital manipulation or physical alteration. The image was continuous, integrated. The watch appeared in proper perspective with correct lighting and focus. If it was added later, it was added with techniques that left no detectable trace. No one at the party remembered anyone wearing such a device. When family members were interviewed separately, none recalled seeing it in the photo when the prints were first collected from the pharmacy. But there it was, years later, undeniably present. This case exists in a database maintained by researchers investigating photographic anomalies. The database contains hundreds of similar reports. A crowd photograph from a 1941 event showing a man in modern athletic wear, specifically branded sneakers and a hoodie displaying a company logo that wasn't created until the 1970s. Security footage from a shopping mall in 2008 showing a person exiting frame through one door, then seconds later entering frame from the opposite direction wearing completely different clothing, impossibly fast for a costume change, and the facial recognition software confirmed it was the same individual. These cases involve older photographs, not easily manipulated digital images, film prints, VHS tapes, media formats that are difficult to alter without leaving forensic evidence. Yet the images show impossibilities. More disturbing are the photographs that witnesses claim have changed. People report looking at old family photos and finding details different than they remember. Different backgrounds, different objects on tables. Sometimes different people when they check earlier descriptions, written notes, journal entries, emails describing the photo. The current version doesn't match what was documented before. Conventional psychology explains this through memory malleability. People misremember what they saw. They reconstruct memories incorrectly. The photograph never changed, their memory of it did. But some cases involve multiple witnesses, several family members independently reporting that a photo has changed in specific identical ways. They describe the photo as they remember it without discussing it with each other, and their descriptions match, but don't match the current image. Statistical analysis suggests this clustering of identical misremembering exceeds what random memory error would produce. Researchers building databases of these reports have noticed patterns. The phenomenon clusters around certain geographic locations, around certain time periods, as if temporal interference isn't T-random but concentrated in specific places and times. The patterns are preliminary, the sample size still small, but the clustering is statistically unusual. Perhaps these are all conventional explanations compounding. Hoaxes, false memories, misidentifications, coincidences stacking into patterns that seem meaningful but aren't. Perhaps photographs don't change, only our memories of them do, and sometimes those false memories align by chance. Or perhaps some photographs contain evidence of temporal interference, images capturing things that weren't there when the photo was taken, but appeared later when the timeline was altered. Physical records that somehow update when history changes, or that document moments when different timelines briefly intersected. The evidence isn't conclusive, but it is accumulating, and it suggests that if temporal interference is occurring, it is leaving traces in the one medium we trust to preserve objective truth. If photographs can change, if time can edit its own records, then detecting temporal manipulation becomes nearly impossible, except for the people who remember the original version and notice when reality doesn't match. But waiting for anomalies to appear isn't enough. If time travel is real, someone must be trying to detect it actively, to measure it, to understand it. And they are. In laboratories and classified programs, researchers are attempting something extraordinary, catching time travelers in the act. Andrew Basiago is a lawyer, licensed to practice in Washington state, graduate of UCLA School of Law, with a conventional professional career that includes nothing particularly unusual, except for one claim that has defined his public life since he began speaking about it in the early 2000s. He says that as a child in the 1970s, he participated in a classified DARPA program called Project Pegasus that achieved time travel using technology based on Nikola Tesla's research. A lawyer claims he was teleported through time as a child in a DARPA program. He named scientists. Some were real. He described places. Some existed. He predicted images from Mars. He was right, but nobody believes him. Basiago's account is detailed and specific. He describes being recruited at age 7, along with other children chosen for their cognitive flexibility and ability to adapt to temporal displacement. The technology, he says, involved a device that created a quantum field allowing objects and people to be teleported through space and time. He claims to have made multiple jumps to different locations on Earth, to different points in history, even to Mars. The mainstream response has been dismissal. His claims sound like science fiction, lack physical evidence, and come from someone with no way to prove any of it happened. Childhood memories are unreliable. Trauma can create false narratives. Attention. Seeking explains why someone would make such claims publicly despite ridicule. But here is what makes his case more complicated than simple dismissal allows. Some details have proven accurate in ways that weren't verifiable when he first stated them. In 2008, he described seeing specific structures and images on Mars during alleged teleportation jumps. He provided detailed descriptions of Martian geography. Years later, when Spirit and Opportunity rovers sent back high-resolution images, some features matched his descriptions with unsettling accuracy. Formations he de-sketched years earlier appeared in official NASA imagery. He claims to have attended Lincoln's Gettysburg Address through temporal viewing technology. His sensory descriptions, the sound quality, the crowd's position, specific details about Lincoln's delivery, contain accurate elements that historians note would require deep research to fabricate. He names scientists allegedly involved in the program. Some were real people working in relevant fields during that time frame, though none have confirmed his claims. His story remains internally consistent across decades of interviews. Details don't change with retelling. He doesn't embellish or expand claims when pressed. He presents documentation, photographs, documents, correspondence that he says support aspects of his account, though none constitute definitive proof. And he is not alone. Several other individuals have come forward claiming involvement in classified temporal research programs. Their stories differ in specifics. Different project names, different decades, different technologies described, but contain remarkable overlap. Multiple whistleblowers independently describe children recruited for temporal displacement experiments, technology involving electromagnetic fields and quantum mechanics, jumps to both past and future timeframes, Mars missions decades before official space programs, scientists and facilities whose existence can be partially verified, similar physiological effects from temporal displacement, nausea, disorientation, memory fragmentation. These whistleblowers face professional consequences, ridicule, loss of credibility. Some have been discredited through campaigns questioning their mental health. Yet they persist in their accounts despite personal cost. Why would multiple people independently fabricate similar stories that bring them nothing but ridicule? The conventional explanation is that they either delusional, seeking attention, or coordinating a hoax. But their accounts emerged at different times, from different backgrounds with no obvious connection between them. The consistency seems too specific for independent fabrication, yet the lack of proof makes verification impossible. Basiago and others claim documentation exists, classified records, program files, participant lists, but remains sealed under national security classifications. They say scientists and officials who could corroborate their accounts are bound by non-disclosure agreements or deceased. The structure of their claims makes them effectively unfalsifiable. You can prove they lying because all confirming evidence is allegedly classified. You can prove they truthful for the same reason. So, what would it take for such claims to be credible? Physical evidence of the technology, declassified documents confirming the programs, multiple independent witnesses with corroborating testimony, predictions or knowledge that couldn't be obtained through conventional means. Basiago and others point to elements of this: accurate Mars descriptions, verifiable scientist names, but none constitute definitive proof. And what would it mean if they were truthful? That time travel has been achieved and classified for decades. That government agencies possess technology allowing temporal displacement. That children were used as experimental subjects in programs the public never knew existed. That everything we've been told about the limits of physics is incomplete at best, deliberately misleading at worst. The whistleblower testimony exists. It is documented, recorded, consistent across multiple sources. Whether it represents truth, delusion, or something in between remains unresolved. But testimony alone, however consistent, isn't the same as proof. For that, we need something more concrete. We need documented programs, declassified research, official acknowledgement that temporal research occurred, even if the results remain classified. And surprisingly, such documentation exists. At the eastern tip of Long Island, overlooking the Atlantic Ocean, sits an abandoned military installation called Camp Hero. The base was active from the 1940s through the 1980s, officially conducting radar operations as part of the Continental Air Defense System. In 1984, the facility was decommissioned. The equipment was shut down. Personnel were reassigned. The site eventually became a state park. According to official records, nothing extraordinary happened there, just routine military operations, then closure when the facility became obsolete. But multiple individuals claim something very different occurred at Camp Hero between 1971 and 1983. Something involving electromagnetic fields, consciousness manipulation, and experiments that tore holes in time itself. A radar facility on Long Island, electromagnetic fields powerful enough to bend space, experiments on children, then sudden abandonment. The government says nothing classified happened there. Their documents suggest otherwise. The claims center around what has been called the Montauk Project, According to witnesses, the facility continued classified research that allegedly began with the Philadelphia experiment, extending it into new territory, using powerful electromagnetic fields, not just for invisibility, but for temporal manipulation. The testimonies describe mind control experiments, time travel technology, and contact with non-human intelligence. These claims sound absurd on their surface, except for verifiable facts that complicate easy dismissal. First, Camp Hero was indeed conducting classified research during this period. The base housed the IPS-35, one of the most powerful radar systems ever constructed. This SAGE radar array could generate electromagnetic fields of extraordinary intensity, powerful enough that some engineers worried about unknown effects on human biology and local space-time geometry. Second, after the base's official closure, urban explorers and researchers discovered extensive underground facilities that weren't mentioned in any official documentation. Tunnels, chambers, equipment rooms, infrastructure far more elaborate than routine radar operations would require. Some equipment remained in place, abandoned hastily rather than properly decommissioned. Third, documents obtained through Freedom of Information Act requests confirm that military facilities during this period conducted classified experiments involving electromagnetic fields, consciousness research, and what internal memos referred to as temporal displacement studies. The documents don't specifically name Camp Hero or confirm the Montauk project, but they establish that such research occurred somewhere. Preston Nichols and Al Bielek are the primary witnesses. Both claim involvement in the Montauk experiments. Nichols describes working as an electrical engineer on equipment that generated rotating magnetic fields designed to create what he calls time portals. Bielek claims to have participated in time travel experiments that sent personnel to different historical periods. Their descriptions of the technology are intriguing. They describe massive electromagnetic coils arranged to create rotating fields, combined with consciousness, interface systems that somehow allowed human intention to guide temporal displacement. This sounds like fantasy until you realize that some modern physics theories propose similar mechanisms, that consciousness might interact with quantum fields, that rotating electromagnetic geometries might warp space-time, that temporal manipulation might require both physical technology and conscious direction. The counter-arguments are substantial. Nichols and Bielek's stories change between tellings. Some details contradict established physics. Skeptical researchers have identified factual errors and timeline inconsistencies. Neither witness provides physical evidence or documentation that definitively proves their involvement. Their credibility has been questioned by mainstream investigators. But here is what remains uncomfortable. Something classified definitely occurred at Camp Hero during the years in question. The electromagnetic equipment was real and extraordinarily powerful. The underground facilities exist. The FOIA documents confirm that temporal research programs operated at military installations during this period. The official explanation, routine radar operations, doesn't account for the infrastructure, the sudden abandonment, or the documentary evidence of consciousness research at similar facilities. Perhaps Nichols and Bielek are fabricating everything, independently or in coordination. Perhaps they were involved in something conventional that they've reinterpreted as exotic. Perhaps they suffered psychological trauma and constructed false memories. These explanations work individually, but the pattern persists. A facility with extraordinary electromagnetic capability. Claims of temporal experimentation. Physical evidence of extensive underground infrastructure. Documentary evidence of related research. Then sudden closure and official silence. If temporal research was conducted at military facilities during the Cold War, Camp Hero would be exactly the kind of location you'd choose. Remote. Powerful equipment already in place. Existing security infrastructure. Easy to classify, easy to deny. The Montauk project might be legend, exaggeration, or deliberate disinformation designed to obscure what actually occurred. But something happened at that facility. The official explanation doesn't fit the evidence. And the unofficial explanations, however fantastical, at least attempt to account for the facts that official records ignore. Whether that research achieved temporal manipulation remains unproven, but the research occurred, and it might still be occurring, just somewhere less accessible to urban explorers and FOIA requests. Near Geneva, Switzerland, beneath the border between France and Switzerland, sits the largest scientific instrument ever built by humanity. The Large Hadron Collider stretches 17 miles in circumference, buried hundreds of feet underground. Inside this massive ring, protons accelerate to 99.9999991%, the speed of light, before smashing into each other with energies measured in trillions of electron volts. CERN, the European Organization for Nuclear Research, operates this facility. Their stated purpose is to investigate the fundamental structure of reality, to recreate conditions that haven't existed since the Big Bang, to discover new particles, new forces, new dimensions, to understand what the universe is made of and how it actually works. The world's most powerful machine creates conditions that haven't existed since the birth of the universe. People's memories started contradicting reality the same month it reached maximum power. CERN's scientists say it is impossible. In 2015, after a 2-year shutdown for upgrades, the LHC restarted operations at unprecedented energy levels. 13 trillion electron volts, nearly double its previous maximum. The collisions occurring inside the accelerator created temperatures over 100,000 times hotter than the Sun. Energy densities that briefly mimicked the first microseconds after the Big Bang. During this same period, something else happened. Reports of Mandela effect spiked dramatically. Online communities tracking false memories noticed a surge in people, discovering their memories didn't match consensus reality. The timing correlation was striking enough that some observers began proposing a connection. Perhaps CERN's experiments weren't just observing reality but affecting it. The hypothesis sounds absurd until you examine what CERN actually researches. Their work isn't limited to finding particles. They investigate the nature of time itself. CERN physicists have published papers exploring temporal symmetry, whether the laws of physics distinguish between time flowing forward versus backward. They've studied whether high-energy collisions might create microscopic temporal reversals, brief moments where cause and effect reverse at quantum scales. CERN scientists have openly discussed theoretical possibilities their experiments might produce. Microscopic black holes that form and evaporate instantly, extra dimensions becoming briefly accessible, space-time itself warping under extreme energy conditions. These aren't fringe speculations, but published considerations from legitimate physicists working at the facility. Several CERN researchers have published papers suggesting that sufficiently powerful particle colliders might, theoretically, cause quantum branching events. The many worlds interpretation predicts that quantum events create branching timelines. Most branches result from atomic scale events. But what happens when you create quantum conditions at energies that haven't existed since the universe's birth? Could those extreme conditions create macroscopic branches, reality splitting in ways that affect not just particles but the timeline itself? If true, anyone near such an event might experience a timeline jump without noticing. Reality would branch, and consciousness would continue in one branch while memories reflect another. The physical world would be subtly different, brand names spelled differently, quotes phrased differently, historical details changed. Not dramatically different, just enough that people notice discrepancies. Skeptics point out obvious problems with this hypothesis. Correlation is causation. Mandela effect reports might have spiked because media attention increased, making people more aware and likely to notice and report false memories. Confirmation bias explains why people connect unrelated events, CERN's operations and memory discrepancies, into a pattern that doesn't actually exist. CERN physicists themselves generally dismiss the connection. They note that particle collisions, even at extreme energies, are localized events affecting tiny volumes of space. The idea that such collisions could alter macroscopic reality or cause widespread consciousness shifts lacks theoretical support and contradicts everything known about how particles and fields interact. But here is what CERN 1T say definitively. It is impossible when asked directly whether their experiments could theoretically affect space-time in ways that might create reality branches. Most physicists hedge. They say it is extremely unlikely. They say current theories don't support it. They say no evidence suggests it is happening. They don't say it is impossible, because the mathematics of quantum mechanics and general relativity, when pushed to extreme energy conditions, permit strange possibilities, reality branching, temporal loops, space-time geometries that our intuition can't accommodate. CERN's experiments probe regimes where our understanding becomes uncertain, where equations suggest possibilities that seem absurd but remain mathematically valid. The research continues. Energy levels increase with each operational cycle. The LHC will eventually be upgraded to even higher intensities, and reports of Mandela effects persist, some people claiming their memories diverge from documented history in ways that cluster around specific dates that sometimes correspond to major CERN operations. Perhaps it is all coincidence and false memory, or perhaps the most powerful machine ever built is doing something its creators didn't anticipate, something involving not just particles but the timeline itself. And if consciousness has any relationship with time beyond simple sequential experience, that would explain why some people notice while others don't. In 1979, Princeton University, one of the world's most prestigious academic institutions, established a laboratory that would spend the next 27 years investigating something most scientists considered impossible. The Princeton Engineering Anomalies Research Laboratory, known as PAIR, was founded by Robert Jahn, former dean of the School of Engineering and Applied Science. Its mission was deceptively simple: determine whether human consciousness could interact with physical reality in ways conventional physics didn't acknowledge. Princeton University spent 27 years proving consciousness can affect the past. The research was impeccable. The results were significant. The university closed the lab anyway. The data still stands. PAIR's experimental protocols were designed to eliminate every conventional explanation. They used random number generators, electronic devices that produced sequences of ones and zeros through truly random quantum processes. Participants sat in front of these machines and focused their intention on influencing the output, trying to make more ones appear than zeros, or vice versa. Pure chance would produce roughly equal numbers. If consciousness could influence physical systems, the ratio would shift. Over millions of trials conducted across 27 years with hundreds of participants, PAIR documented exactly such shifts. Small deviations from chance expectation that occurred consistently across different participants, different sessions, different time periods. The effect size was tiny, shifting the ratio by only a fraction of a percent. But statistically across millions of trials, the deviation was significant. The probability that this resulted from chance was less than 1 in a billion. Critics immediately focused on the effect. Smallness, a fraction of a percent, hardly seems revolutionary. But PAIR researchers pointed out something crucial. Any effect, regardless of size, if it demonstrates consciousness influencing physical systems through no known mechanism, requires fundamental revision of our understanding of reality. The magnitude matters less than the existence. Even a tiny crack in the wall separating mind and matter suggests the wall isn't as solid as we assumed. But PAIR investigated something more directly relevant to time travel. They conducted experiments on precognition, whether consciousness could influence events occurred. Participants focused their intention on influencing a random number generator's output before the device was activated. They attempted to affect the past, or what would become the past once the future trial occurred. The results were disturbing. In some experimental conditions, the precognitive effect was stronger than the real-time effect. Participants influenced future random events more successfully than present ones. Human intention appeared to reach forward in time, affecting outcomes that hadn't been generated yet, or backward from the future moment, when the device would activate to the present moment when intention was focused. The experimental design eliminated conventional explanations. The random number generation was truly random, based on quantum decay processes with no predictable pattern. Participants had no sensory information about outcomes. The timing was controlled and randomized, yet the statistical deviation persisted across thousands of sessions. PAIR subjected their findings to rigorous peer review. They published in mainstream scientific journals. Independent researchers attempted replications. Some replications found similar effects, though not all. The phenomenon appeared subtle and dependent on factors researchers didn't fully understand. But meta-analyses examining multiple studies showed that overall, the effect remained statistically significant across independent laboratories. The implications troubled mainstream science. If consciousness can influence random physical systems, especially future random systems, then the neat separation between observer and observed breaks down. Time stops being a one-way flow immune to consciousness. Causality becomes more complicated. The materialist worldview that treats consciousness as an epiphenomenon produced by brain chemistry, but powerless to affect physical reality, faces serious challenge. Princeton kept PAIR operational for 27 years, an extraordinary duration for any experimental program, but funding became difficult as the implications grew more uncomfortable. In 2007, the laboratory closed, not because the research had failed or been disproven. The data stood, the statistical analyses held, but institutional support evaporated. The university didn't want to be associated with findings that seemed too strange, too controversial, too challenging to conventional physics. The laboratory closed, but the data remains. Published, available, analyzed by independent statisticians who confirm the statistical significance. PAIR demonstrated that consciousness interacts with physical reality in ways orthodox science doesn't accommodate. And more specifically, that this interaction appears to transcend normal temporal boundaries, human intention affecting outcomes before those outcomes are determined. If consciousness can reach forward or backward in time by even microseconds in laboratory conditions, what does that suggest about the relationship between mind and time itself? The 21st of October 1966, a coal waste tip above the Welsh village of Aberfan became unstable after heavy rain. At 9:15 a.m., it collapsed. 2 million cubic feet of black sludge slid down the mountain, burying Panglas Junior School and several houses. 144 people died. 116 were children. The disaster shocked Britain. But what shocked psychiatrist John Barker, who travelled to Aberfan to help survivors, was something else. People kept telling him they'd known it was going to happen, not a vague sense of unease. Specific dreams describing exactly what occurred. Days before the collapse, 76 people dreamed of a disaster before it happened. They reported it. Days later, 116 children died exactly as they described. Psychiatrists documented everything. Science still can explain it. Barker was a respected psychiatrist, not prone to accepting supernatural explanations, but as a trained investigator, he documented what witnesses reported. He interviewed people who claimed premonitions about the disaster. He required proof that their premonitions occurred before the event. Witnesses who heard the dream described, written records, dated documentation. He found 76 cases that met his criteria. People who had told family members, friends, or written in journals about dreams of black material sliding down a mountain, engulfing a school, children in danger. Some dreamers had never heard of Aberfan before their dreams. Several described the village by name. One child who died in the disaster had told her mother the day before, "I am not afraid to die. I shall be with Peter and June, 2 classmates." She dreamed of something black covering the school. Statistical analysis showed the clustering of these premonitions around one specific disaster, all occurring within days of the event, exceeded chance probability by astronomical margins. If dreams randomly predict disasters, they should be distributed evenly across time and events. These clustered with precision around Aberfan. This case is in T-isolated. Morgan Robertson published a novel in 1898 called Futility, about the largest ship ever built, called the Titan, designated as unsinkable, carrying insufficient lifeboats. In the novel, the Titan hits an iceberg in the North Atlantic and sinks with massive loss of life. 14 years later, the Titanic, nearly identical in size, also called unsinkable, also with insufficient lifeboats, hit an iceberg in the North Atlantic and sank. The similarities extend beyond broad strokes to specific technical details: tonnage, passenger capacity, speed at collision. Mark Twain documented a dream about his brother Henry's death in a riverboat explosion. He described seeing Henry's body in a metal coffin, wearing a suit, with a bouquet of white flowers with a single red flower in the center resting on his chest. Weeks later, Henry died exactly as described. The funeral arrangement matched Twain's dream precisely. Twain had documented the dream in letters before the event, so retroactive falsification isn't possible. Psychological explanations exist. Coincidence. Enough people dream about disasters that some dreams will accidentally match real events. Retroactive falsification. People misremember their dreams after events occur, unconsciously adjusting details to match reality. Pattern recognition. Dreams are random, but our brains find patterns in randomness, creating false correlations. But research published in the Journal of Scientific Exploration found that documented premonitory dreams contain statistically unusual amounts of accurate specific details compared to ordinary dreams. The specificity, names, dates, precise visual details, exceeds what coincidence explains comfortably. Theories attempting to explain precognitive dreams often invoke consciousness and time's relationship. Perhaps during sleep, when the rational mind quiets, consciousness experiences time non-linearly. Perhaps information from future events leaks backward through quantum processes that neural tissue somehow accesses. Perhaps dreams aren't always about processing past experience, but sometimes about perceiving future experience, information arriving from tomorrow that the waking mind filters out. These theories sound mystical until you remember quantum experiments showing information traveling backward in time, presentiment studies showing physiological responses preceding stimuli, pair research demonstrating consciousness affecting future random events. Perhaps precognitive dreams are the same phenomenon observed in natural, uncontrolled conditions. Consciousness interacting with time in ways that become noticeable during sleep when normal filtering mechanisms are inactive. Dreams remain subjective, uncontrolled, difficult to study rigorously. But the documented cases, particularly disasters where multiple independent witnesses report similar premonitions before the event, suggest something beyond coincidence or false memory, something about consciousness and time that orthodox neuroscience doesn't acknowledge. But dreams are involuntary, random. What if consciousness could access future information deliberately? For over 20 years, the CIA maintained a classified program investigating something that shouldn't exist according to conventional neuroscience. They called it various names: Grill Flame, Center Lane, Sunday Streak. Eventually, it became known as Stargate. The objective was remote viewing, determining whether trained individuals could perceive locations, objects, or events at a distance using only their minds. The CIA trained people to see through walls. Some saw through time instead. The program was classified for 20 years. When they released the files, one thing became clear: it worked. Sometimes this wasn't fringe research conducted in basements. Physicists Russell Targ and Harold Puthoff at Stanford Research Institute developed the experimental protocols. Participants underwent rigorous screening. Sessions followed strict scientific methodology. Double-blind protocols ensured viewers received no sensory information about targets. Results were documented and analyzed by independent evaluators. Some sessions produced remarkable results. Viewers accurately described classified military facilities they never seen. They located missing aircraft. They provided intelligence about foreign installations that was later verified by satellite imagery. Not consistently, the success rate varied wildly, but frequently enough that intelligence agencies maintained funding for 2 decades. But something stranger emerged during specific experimental sessions. Remote viewers sometimes performed better when targeting future events than current ones. Sessions where viewers were asked to describe a location that wouldn't be selected until after the viewing session. Logically, this should be impossible. The target doesn't exist yet. There is nothing to perceive, yet viewers provided accurate descriptions. They drew sketches matching locations that researchers would randomly select until hours or days later. The temporal paradox was unavoidable. Viewers were perceiving information from their own future, from the moment when they would receive feedback about the actual target. The CIA's own assessment report, declassified in 1995, acknowledged this disturbing finding. The report stated that remote viewing produced information that wasn't easily explained by known sensory or cognitive channels. It concluded the phenomenon was real, but not reliable enough for consistent intelligence operations. Too variable, too dependent on factors researchers did understand. But declassified documents reveal something the public report downplayed. The program didn't actually end. It was restructured, reclassified, moved to different agencies. The research continued under classifications that remain active. Former military remote viewers have spoken publicly about temporal viewing protocols. Joseph McMoneagle, who participated in Stargate, described methods for targeting past or future events. The protocols weren't different from spatial remote viewing. Viewers entered similar mental states, received similar coordinate systems, but temporal targets often produced more accurate data than spatial ones. This puzzled researchers. Conventional understanding suggests perceiving distant locations should be easier than perceiving different time periods. Both are impossible, according to mainstream neuroscience, but temporal displacement adds an extra layer of impossibility. Yet viewers consistently reported that time felt more accessible than space, as if consciousness naturally moved through temporal dimensions more easily than spatial ones. The declassified findings suggest that human consciousness might have an inherent relationship with time that goes beyond sequential experience. That, under certain conditions, specific mental states, particular training protocols, reduced sensory input, consciousness can access information from past or future events, not reliably, not controllably, but measurably above chance. Intelligence agencies invested millions into this research because it occasionally worked, because trained viewers sometimes described things they couldn't possibly know through conventional means, and because temporal viewing, when it succeeded, provided the most accurate results. The implications extend beyond military intelligence. If consciousness can perceive future events, even unreliably, that suggests time isn't a barrier to awareness, that the present moment might not be the only moment consciousness can access, that perhaps the reason we normally experience time linearly is limitation or habit rather than fundamental constraint. Pair showed consciousness affecting future random events. Presentiment studies showed physiological responses preceding stimuli. Precognitive dreams showed future events entering awareness during sleep. Remote viewing adds another layer, trained individuals deliberately accessing temporal information under controlled conditions. Each phenomenon individually might be dismissed. Collectively, they suggest something profound about consciousness and time, something that challenges materialist assumptions about mind being produced by brain chemistry and trapped in sequential experience. But what does it all mean? If consciousness can interact with time, if temporal anomalies occur, if time travel might be possible through physics or perception, what are the implications for how we understand reality itself? We've traveled through physics equations and historical anomalies, through consciousness experiments and government programs, through testimonies and documented cases. Each piece of evidence stands alone, intriguing but not conclusive. But when you step back and observe the pattern they create together, something becomes clear. Multiple independent lines of investigation are pointing toward the same unsettling conclusion. Time might not be what we think it is. What if time doesn't flow? What if every moment exists simultaneously, and consciousness just travels through them? What if now is an illusion, and everything, past, present, future, is equally real? The block universe theory in physics proposes exactly this. According to this view, space-time is a four-dimensional structure where all moments exist eternally. Past, present, and future are equally real, laid out like frames in a film strip. What we experience as the flow of time is just consciousness moving through this static structure, illuminating one moment after another. The flow is subjective, an artifact of how awareness works, not a fundamental feature of reality. If this theory is correct, and it is consistent with relativity, then the past still exists somewhere in spacetime's geometry, and the future already exists there too. Both are potentially accessible, not because we're changing them, but because they're already there, frozen in the eternal structure of spacetime. This raises immediate questions about free will. If the future already exists, are our choices predetermined? Are we just experiencing the illusion of choice while following a script already written? The many worlds interpretation offers one resolution. Perhaps every choice does exist in the block universe, but as separate branches. Your choice creates which branch you experience, but all possible choices exist in the complete structure. What we call time travel might actually be consciousness, shifting between different temporal perspectives within this block, or jumping between branches in the quantum multiverse. Not traveling in the sense of moving through space, but transitioning between different slices of an eternal structure. Some physicists propose something even stranger. Time might not be fundamental at all. It might be emergent, arising from deeper quantum processes, the way temperature emerges from molecular motion. If time emerges from quantum entanglement and thermodynamic processes rather than being woven into spacetime's fabric, then, under certain conditions, extreme energy states, specific quantum configurations, altered consciousness states, the emergence might break down. Time might become locally accessible in non-linear ways. This would explain why temporal anomalies seem to occur at quantum scales during high-energy particle collisions, in consciousness states where normal neural processing is altered. These aren't violations of time's laws. They're conditions where time's usual emergent structure becomes temporarily unstable. The evidence we've examined suggests time travel might not be one phenomenon, but several related phenomena. Quantum retrocausality, allowing information to flow backward at microscopic scales. Consciousness accessing temporal information during dreams or altered states. Physical manipulation of space-time through extreme gravitational or electromagnetic conditions. Quantum jumping between adjacent timeline branches, each operating through different mechanisms, but all revealing the same underlying truth. The boundary between past, present, and future is more permeable than everyday experience suggests. Perhaps what we experience as linear time is like a language, a useful framework for navigating reality, but not the deepest description of what reality is. We experience time as flowing forward because that is how our consciousness is structured, how our neurons process causality, how evolution shaped perception, but the territory might be stranger than the map we use to navigate it. If any of this is true, it transforms fundamental questions. What is choice if the future already exists? What is memory if the past remains accessible? What is causality if effects can precede causes? What is consciousness if it can access moments outside its temporal location? These aren't just abstract philosophical puzzles. They have practical implications for how we live, how we make decisions, how we understand our place in reality. Because if time is an illusion or an emergent property rather than fundamental structure that changes everything about what is possible, imagine you possess knowledge of a disaster that will kill hundreds of people next week. You know the location, the time, the cause. You could prevent it, save all those lives. The choice seems obvious, but prevention creates ripples. Those hundreds of people don't die. They continue living, making choices, having children. Within a generation, thousands of people exist who wouldn't have existed if the disaster occurred. Now imagine you could travel back further, prevent a different tragedy from decades ago. The ripples become waves. Millions of people in your present might never be born. Millions of others who don't exist now would exist instead. If you could prevent a tragedy by changing the past, but doing so would erase the existence of people born after the event, should you? How many people is one person worth? This isn't abstract philosophy. If temporal manipulation is possible through technology, consciousness, or quantum effects, these questions become urgent. Every intervention carries consequences that cascade forward, rewriting futures in ways you can predict or control. Consider a simpler case: temporal knowledge without the ability to change events. You dream about a disaster before it happens. You tell authorities, they dismiss you. Dreams aren't evidence. The disaster occurs exactly as you foresaw. Are you responsible for not trying harder to convince them? Or would trying harder have simply marked you as unstable, ensuring you be ignored? People reported premonitions before the 11th of September 2001, before major earthquakes, before plane crashes. Some tried reporting their knowledge, most were dismissed. A few were investigated as potential suspects. If you knew about the attack, maybe you were involved in planning it. The ethical burden of unverifiable future knowledge is genuine and painful. Now consider darker possibilities. If time travel technology exists and operates in classified programs, who decides how it is used? What ethical framework governs interventions in history? Should any government possess the power to alter timelines? If they use that power, do they have obligation to inform affected populations? And if timelines are altered, how would anyone know to object? Perhaps temporal manipulation has already occurred. Perhaps the timeline you are experiencing is version 7, shaped by interventions you are unaware of. Perhaps disasters were prevented, wars were shortened, outcomes were adjusted. You never know. The only timeline you can experience is the one you are in. Ethics requires consent and transparency, but temporal manipulation makes both impossible for affected populations. Then there is temporal justice. If someone commits a crime and time travel prevents that crime from occurring, is the person still guilty in the new timeline? They committed the act in the original timeline, but in the timeline everyone now inhabits, the act never happened. Do you punish someone for a crime that didn't occur? Do you not punish them despite knowing they were capable and willing? Personal ethics become equally complex. If your consciousness accesses future information through dreams, intuition, presentiment, is acting on that information ethical? Are you cheating fate or fulfilling destiny? If you avoid danger because of precognitive awareness, did you create the timeline where you survive, or were you always meant to survive, and the premonition was how? These questions lack easy answers. Philosophy and religion have grappled with determinism and free will for millennia without resolution. Adding temporal manipulation creates new dimensions of ethical complexity. Perhaps humanity needs to develop frameworks before temporal technology becomes widely accessible, if it hasn't already. Principles governing who can access temporal knowledge, restrictions on timeline manipulation, protocols for handling precognitive information, protections for temporal research subjects, or perhaps the absence of such frameworks suggests temporal technology remains safely theoretical. Perhaps the questions remain philosophical because the capabilities remain impossible. But if any of the evidence we've examined is valid, these questions won't stay hypothetical forever. And when they become practical, we need answers. You're not going to build a time machine in your garage. You're not going to access classified government programs or manipulate quantum fields in your living room. The technologies and capabilities we've discussed remain far beyond individual reach, if they exist at all. But that doesn't mean this investigation is purely theoretical. Understanding that time might be stranger than you were taught changes how you experience every moment. You can't build a time machine, but you can live like time is stranger than you were taught. Start paying attention to your intuitions. Start documenting coincidences. Start noticing when things feel out of time. Begin with intuition. That feeling when you think about someone seconds before they call. The sense that you shouldn't take a particular route home. The dream that feels different from normal dreams, heavier with significance. Most people dismiss these experiences as coincidence or imagination. But if consciousness has any relationship with time beyond sequential experience, these feelings might be accessing information from adjacent moments, perceiving what is about to happen before it fully arrives in your awareness. Paying attention doesn't mean becoming superstitious. It means noticing patterns without forcing meaning onto randomness. Keep a journal. Document when intuitions prove accurate. Track patterns. You might discover that certain types of feelings correlate with certain types of outcomes more reliably than chance would predict. Or you might discover they don't. Either way, you've engaged with the question directly rather than assuming the answer. Mindfulness takes on different significance if time is not what it seems. Being fully present in this moment isn't just therapeutic advice. It is engagement with reality's fundamental nature. If all moments exist simultaneously in a block universe, then this moment right now is as eternal as any other. Your awareness moving through it doesn't make it less real. And if consciousness can navigate time non-linearly, then being fully present might be the foundation for accessing that capability. Quantum retrocausality studies suggest something practical. Your future intentions might influence your present circumstances, not mystically, but through quantum mechanisms we're beginning to understand. This implies that clarifying what you want, forming clear intentions about future states, might have backward-reaching effects. Not guaranteed. The experiments show small statistical effects, not reliable control. But perhaps intention matters more than we realized, acting on reality in subtle ways that accumulate over time. Keep a dream journal. Most dreams are mental noise, processing, organizing, random neural firing. But occasionally, dreams contain specific details about events that haven't occurred yet. You won't know which dreams are precognitive until after the fact, but documenting them creates a record. When future events match dream content, you'll have evidence of something strange happening in your own experience. Document synchronicities, meaningful coincidences, times when reality seems to respond to your thoughts, when the right person appears at the right moment, when circumstances align impossibly well. Carl Jung spent decades investigating synchronicity. Coincidences too meaningful to be random. Perhaps these moments are windows into temporal mechanics we don't understand. Approach time with less rigidity. Deadlines and schedules are useful constructs, but they're not ultimate reality. Too late might sometimes be wrong. The past might be less sealed than you assume. Not because you'll literally travel backward, but because how you relate to past events continues shaping them in memory and meaning. The future might be less fixed than anxiety suggests. Possibilities remain open longer than conventional wisdom allows. This doesn't require believing in time travel. These practices are valuable, regardless of whether temporal anomalies are real or illusions. They cultivate awareness, presence, and openness to possibility. They transform how you experience reality, even if reality operates exactly as conventional physics describes. But if time is stranger than we've been taught, these practices might reveal that strangeness in your own life, and that is when things get interesting. The investigation we conducted is in Just Historical Archaeology, examining old mysteries and declassified programs. While you've been reading this, while you've been questioning what time actually is, researchers in laboratories across multiple continents have been conducting experiments that push temporal boundaries further than ever before. Right now, in laboratories you've never heard of, scientists are conducting experiments their predecessors would have considered impossible. Some are succeeding. None are telling you what they found. In 2022, quantum physicists published research in a peer-reviewed journal demonstrating that quantum systems can be observed in reverse temporal order, not theoretically, actually measured. Events occurring in sequence A, B, C were observed as C, B, A without violating causality. The paper was technical, buried in specialized literature, received minimal mainstream attention, but it demonstrated something profound. temporal order is in T absolute even for macroscopic measurement systems. DARPA has stopped funding temporal research. Their current programs don't advertise themselves as time travel projects. They use terms like advanced temporal perception, retrocausal information processing, and quantum temporal optimization. But the research objectives are clear, determining whether temporal effects demonstrated in quantum experiments can be scaled, enhanced, or applied to practical problems. Funding continues, programs expand. They wouldn't invest if results were consistently negative. Private companies have entered the field. Several quantum computing firms are exploring applications that leverage temporal effects. If quantum computers can access information from their own future states, even microseconds ahead, that represents computational advantage over classical systems. Some companies claim they are already demonstrating this in prototype systems. Their patents describe temporal information channels. Their research papers, carefully worded, suggest they exploiting retrocausality for computation. Universities now host dedicated research groups investigating temporal phenomena, though rarely under explicit time travel labels. At Caltech, researchers study quantum temporal manipulation, how to control the direction and rate of time flow for quantum systems. The Quantum Gravity Research Institute investigates consciousness and time, exploring whether awareness has temporal properties that physics hasn't accounted for. Multiple institutions study whether quantum entanglement allows information transfer not just across space, but across time. These aren't fringe operations. They legitimate research programs with published findings, graduate students, peer review. The field has moved from science fiction to legitimate inquiry, slowly, carefully, with appropriate skepticism, but definitively. Some researchers believe we approaching a breakthrough, not a Hollywood time machine that sends people to arbitrary dates, but technologies allowing limited temporal perception, seeing seconds or minutes ahead with reliability better than chance. Quantum information systems that transmit data to their own past states. Methods for manipulating local time rates, creating regions where time passes differently than surroundings. These capabilities sound modest compared to fiction's vision of time travel, but they would be revolutionary. Much research remains classified. Military applications of temporal technology are obvious. Early warning systems, enhanced decision-making communication channels immune to conventional interception. Economic applications are equally powerful. Markets become predictable. Competitors' strategies become visible before implementation. Any breakthrough in temporal technology would represent perhaps the most strategically valuable capability ever developed. This raises uncomfortable questions. Who controls temporal research? What regulations govern its development? If temporal manipulation becomes possible, what prevents abuse? International treaties restrict nuclear weapons, biological agents, space-based weapons. Nothing addresses temporal technology because officially it doesn't exist. But research continues. Funding flows, papers publish, patents filed, and somewhere in classified programs with innocuous names, researchers might be achieving capabilities that would transform everything about how power, knowledge, and causality function. The future of temporal research is happening right now, and most of it is invisible. Predicting the future is notoriously unreliable, but sometimes you can see the trajectory. Watch where research is heading, identify what is theoretically possible but technologically premature, and extrapolate forward with informed humility. When you do that with temporal research, several possibilities emerge that seem plausible within decades rather than centuries. Within your lifetime, someone might develop technology that manipulates time. When they do, everything changes, including perhaps the moment you are experiencing right now. Quantum computers already operate strangely with respect to time, maintaining superposition states that classical physics says shouldn't exist, processing information in ways that seem to transcend sequential computation. The next evolution might be temporal computation, quantum systems that don't just process faster, but access their own future states to solve problems. Imagine a computer that runs calculations, observes the answer in its future, then uses that information to reach the solution more efficiently in its present. The mathematics supporting this already exist in quantum mechanics. The engineering challenge is making it reliable and scalable. Neuroscience combined with quantum physics might produce technologies for enhanced precognition. Not supernatural foresight, but amplification of natural temporal perception that presentiment studies have already demonstrated. Brain-computer interfaces that detect and enhance the subtle physiological responses occurring before future events. Training protocols that strengthen whatever mechanism allows consciousness to access temporal information. This wouldn't give you detailed visions of distant futures, but it might extend your perceptual window from the present moment to seconds or minutes ahead with reliability significantly above chance. Controllable temporal dilation seems more accessible than backward time travel. Technology creating localized fields where time passes at different rates than surrounding space. Medical stasis that slows biological processes to near zero, preserving patients until treatment becomes available. Manufacturing environments where time accelerates, completing processes in subjective hours that require objective days. The physics allowing this already exist in general relativity. Extreme gravity or velocity manipulates time rates. The challenge is creating those conditions artificially without requiring planet-sized masses or near light speeds. Perhaps strangest, improved understanding of consciousness and time might reveal that temporal perception does require technology at all. Perhaps certain meditative states, specific cognitive practices, or particular neural configurations naturally allow awareness to extend beyond the present moment. Perhaps remote viewers and precognitive dreamers aren't anomalies, but people who accidentally discovered what humans can do with proper training. Time travel might not require machines but consciousness development. Each possibility requires breakthroughs, but none violates known physics. None requires discovering new fundamental forces or particles. They re-engineering challenges and consciousness mysteries rather than impossibilities. The societal implications would be profound. Economics transforms if futures become partially predictable. Warfare changes if commanders perceive enemy actions seconds before they occur. Relationships shift if partners can sense emotional futures. Social structures reorganize around whoever controls temporal technologies. Even limited capabilities, seeing minutes ahead, slowing time locally, accessing quantum temporal information, would represent a revolution more significant than electricity or computing. Every transformative technology seemed impossible until suddenly it wasn't. Heavier than air flight violated common sense until 1903. Instantaneous global communication seemed magical until it became ordinary. Computers that fit in pockets and access humanity. Collected knowledge would have seemed fantastical to someone in 1950. Yet here we are, treating miracles as mundane. Perhaps temporal technology follows the same pattern, impossible until someone demonstrates it. Then inevitable, then ordinary. The question is whether it will happen, but when, and whether we recognize it when it arrives. Because if the research trajectories continue, if the experiments keep producing positive results, if the classified programs achieve what their funding suggests they pursuing, then temporal technology is a distant dream. It is approaching. And when it arrives, everything about causality, choice, and consequence transforms, including, perhaps, the moment you are experiencing right now, shaped by futures you haven't reached yet and pasts you already forgotten. We began this investigation in the dark hours of early morning, lying awake with memories we wished we could change and futures we longed to see. We asked whether the impossible might be possible, whether time travel in any form might be real. Now, 20,000 words later, after examining physics and anomalies, consciousness and classified programs, what have we discovered? The honest answer: we haven't proven time travel exists. Not definitively, not in a way that would convince every skeptic or satisfy every scientist. The evidence remains circumstantial, suggestive, incomplete. Testimonies without physical proof. Experiments showing effects but not mechanisms. Theories permitting possibilities without guaranteeing actualities. But perhaps we've demonstrated something more important. Time itself is far stranger than everyday experience suggests. The boundary between past, present, and future might be more permeable than we've been taught. And the question of time travel opens doors to deeper mysteries about consciousness, reality, and what existence actually means. Each viewer must draw their own conclusions. You've seen the evidence. You've encountered theories from respected physicists and testimonies from credible witnesses. You've examined experiments showing temporal anomalies and programs investigating possibilities that shouldn't exist. Whether you conclude time travel is real, impossible, or somewhere in between depends on how you weigh that evidence. But regardless of your conclusion, something has changed. You can't unsee what you've seen. You can't unknow what you've learned. Time isn't the simple forward flow you once assumed. Reality contains mysteries that conventional wisdom dismisses too quickly. So could time travel be real? After everything you've seen, you have to answer that yourself. But here is the real question. If it is, what are you going to do about it? Return to the human element we started with, that longing to revisit the past, to see loved ones again, to correct mistakes. That hunger to glimpse the future, to know how your choices turn out, to see what comes next. That desire to transcend time's apparent tyranny. Whether or not physical time travel becomes possible, understanding time's complexity offers a different kind of liberation, freedom from anxiety that you're running out of time. Perhaps you're not, if time isn't what you thought. Freedom from regret that opportunities are lost forever. Perhaps they remain accessible in ways we're discovering. Freedom from fear that the future is rigidly determined. Perhaps it branches with every choice, creating possibilities rather than following fate. The most important journey through time might not be backward or forward. It might be deeper, into understanding the nature of this moment you're experiencing right now. This exact second, which might be stranger, more eternal, more malleable than you ever imagined. Time travel might remain forever theoretical, or it might be discovered tomorrow. Or it might already exist, hidden in classified programs and quantum effects and consciousness capabilities we're only beginning to understand. But the real journey isn't waiting for definitive proof. It is living with new awareness, paying attention to temporal anomalies in your own experience, questioning what you've been taught about time's nature, remaining curious about possibilities that seem impossible until suddenly they're not. The question remains open, not because we lack answers, but because the question itself transforms how you experience reality. And perhaps that is more valuable than any answer could be. Time is waiting, or perhaps it is not waiting at all. Perhaps it is already here, already there, already everywhere. And you're finally beginning to notice.